Welcome to this live lesson on data analysis fundamentals with Excel. During this live lesson, we will introduce many Excel capabilities and best practices that are fundamental to setting up complex and sustainable data analysis models. First, a little bit about myself. For the past 20 years, I've been involved with data analytics in some form or fashion across the Microsoft suite of products. I'm a Microsoft certified trainer. I'm a Microsoft certified solutions expert in data analytics. And I'm the author of Analyzing and Visualizing Data with Microsoft Excel, which was published by Microsoft Press. I'm an architect, coach, trainer, and speaker. And I'm also a community leader in the business applications and Azure suite of products.
And now a little bit about myself. Over the last 15 years, I have designed, implemented, and supported various Excel-based solutions. My other engagements have required strategic business analysis, portfolio planning, management reporting, project management, and technical leadership. Through these engagements, I have had the opportunity to consult for individual professionals, small, medium-sized businesses, as well as large multinational corporations within various industries. Over the last few years, I have been leveraging Microsoft 365 and Power Platform to provide consulting services related to advanced Excel modeling, data cleanup and processing, business data analysis, and other business intelligence solutions.
We will be your guides as we explore and introduce the fundamentals of data analysis with Excel. You'll be hard-pressed to find an organization this day and age that does not want to become more data-driven. The big question is, how do we get there? As you might imagine, this involves much more than implementing technologies alone. At the ground level, it really starts with producing reliable data, which can be later consumed to produce an accurate and timely picture of business performance. As you will see throughout this course, there is a lot we can do to better enable this. Most organizations have a love-hate relationship with Excel, and this is for a variety of reasons. But Excel is a powerful tool when used properly. Admittedly, I spent a lot of years helping organizations that have struggled with data quality issues relating to Excel-based solutions. As a data consumer, it was relatively easy to focus on Excel as the root cause. But now that I reflect back, I realized there was more to the story. My lack of perspective was due to the fact that I mostly spent time as a data consumer and rarely walked in the shoes of a data producer. We find this disconnect is not uncommon across most organizations. So what is the root cause of this? We trace it back to a few reasons. First being training and education on how to best use Excel. Most people just figure it out on the fly. Secondly, there's a general lack of understanding of best practices around how to build complex, sustainable, and shareable models. And lastly, a lack of understanding for data lifecycle and where stakeholders fit. Let's just say this: Excel is not going anywhere. Its use is ubiquitous and flexible. It's used to manage entire processes or to augment processes and operational systems.
For the content in this course, we assume you're comfortable with the basic Excel features and capabilities related to menus and navigation, workbook components, and authoring formulas. During this live lesson, we want to demonstrate how to design, build, and share complex Excel solutions that can be sustained over the long term. We suggest you to be patient as we discuss some concepts and best practices that might not make sense right out of the gate. We will continuously reinforce these themes and highlight their benefits as we progress through the materials. The topics we discuss will include getting started with data analysis in Excel, using get and transform data, structuring and referencing data for analysis, preparing and analyzing data, authoring interactive reports, and setting up for collaboration and distribution.
Do we still have you? We hope so. We have lots to learn. So let's get started.
If you're still left wondering if this course is for you, let's look at a question we're often asked by intermediate Excel users. I want to get into analytics. Where do I start? If you're already a data analyst, you may be struggling with, how can I use Excel more effectively to do my job? Both these scenarios are addressed in this lesson as we walk you through examples and best practices for leveraging Excel for your data analysis needs.
In this course, we will teach you how to use Excel efficiently and effectively in a hands-on manner so that you can more easily manage business processes such as sales, commissions, time tracking, invoicing, vacation tracking, budgeting and forecasting, and many more. To manage these processes, we often follow a consistent pattern. Let's use an invoice management process as an example. Here, we first must import data. Maybe we need to get timesheet data into Excel from a time tracking system. Next, we add in hourly rates so we can determine the amounts to bill. And this amounts to data entry in some form or fashion. Next, we may or may not want to do some data validation, answering such questions as, did we enter too many hours or not enough? Does this invoice seem reasonable? And this is data preparation. Next, with the above steps completed, we can generate timely and accurate invoices that we are confident in. And this is reporting. And last but not least, we need to distribute the invoices to our clients. And here we will talk about distribution methods. And thinking about the whole picture now, we may use the invoice management process spreadsheet to track when invoices are due and if they are paid or not. There is a whole lot more we can do here, but let's keep the example simple to start. Every Excel workbook exists within a larger data ecosystem. This includes other workbooks that may be from other users, and database systems such as ERPs, CRMs, and other operational systems. Each of these systems contains organizational data, and it is important to understand how all these relate in the larger data lifecycle. Let us talk about Excel in the context of the data lifecycle so we can better understand its role as a technology in the lifecycle. In this course, we have a theme of framing the data lifecycle using people, process, technology, and data. For example, let's use an invoice management process. In the middle, we have Excel as our technology, and within Excel, we have data. We then have data producers, which put data into systems. Data producers often acquire data, and they may perform additional data entry and manipulation steps to support that process. Data consumers often use data for reporting on a process or to integrate data into other processes. To manage these processes, we often follow a consistent pattern. Once again, let's use the invoice management process as our example. Maybe we need to get timesheet data into Excel from a time tracking system. For this, we would import data. Next, maybe we need to add in hourly rates so we can determine the amount to bill. This would amount to some data entry in some form or fashion. Next, we may do some data validation, answering such questions as, did we enter too many hours or not enough? And does this invoice seem reasonable after all of my calculation steps have occurred? With the above steps completed, we can generate a timely and accurate invoice that we're confident in. And this would be a reporting process. And last but not least, we would then look to distribute our work to our clients. And thinking about the whole picture now, we may use the invoice management process spreadsheet to track when invoices are due and if they're paid or not. There's a whole lot more we can do here, but let's keep this example simple to start. So how do we go about creating reliable data as a producer? It all starts with people. We need to train our people on how to use data capture and management tools effectively from a tool perspective. This is training people on the technologies. Next, we need to build good processes using those technologies that are easily understood and followed. Our end goal of all this is high quality data. And we can achieve that if we manage the above interactions well. With confidence in the producer processes, consumers can pick up on data that is timely and accurate to help paint a picture of business performance and do it with confidence. Keep in mind that often the root cause of bad data is some deficiency in the data producer phase of the data lifecycle. With that, the focus for the majority of my career has really been around data consumption and I was rarely exposed to the typical data producer activities. But recently, I've been spending more time as a data producer within my own organization. I believe that bringing a ground-up focus to people, process, technology, and data, and embedding into the fabric of our company will help us become a more data-driven organization that can make timely and accurate decisions with confidence.
Complementing Chris's experience, most of my career I have worked with and supported data producers within operations, finance, financial and production accounting, treasury, supply chain, and several other business functions. I have witnessed firsthand how trained data producers and optimized data flows, including manual data entry, can simplify downstream data preparation activities and significantly enhance the analytical capabilities for data consumers. I have also noticed that although Excel is a core component for data analysis, in most companies, it is not one of the primary focuses for their skills training and development programs. During this live lesson, we will leverage our experience as data producers, modelers, and consumers to highlight some fundamental Excel capabilities and best practices relevant to a typical data analyst role. Before we begin with the core materials, let's review Excel versions, especially in context of Microsoft 365. With the advent of cloud solutions, software nowadays is deployed at a much faster pace than a few years ago. In that context, Microsoft Excel is no exception. Historically, new versions of Excel were released as packaged retail versions, like Excel 2013, 2016, and 2019. However, with Microsoft 365 apps, the solution has moved to a subscription-based model, wherein new features, issue resolutions, and security updates are released periodically as per the policies of the selected update channel. The three primary update channels are current, monthly, and semi-annual. Your company's selected update channel will determine how often your copy of Excel is updated with the latest features and patches. If your copy of Excel is included with the Microsoft 365 subscription, you can check your specific version using the following navigation sequence: File, Account, and then look under the About Excel section. This navigation sequence might be different depending on your version of Excel. For this live lesson, we will be using Excel version 2006 as deployed within the current channel of Microsoft 365 apps. Depending on your version of Excel, you might notice some differences with menus, functions, options, and other features used within this live lesson. For the best learning experience, we recommend you update to the latest version of Microsoft 365 Excel. So with that, let's begin.
As data analysts, chances are you've spent or will spend a lot of time wrangling data that comes in many shapes and sizes and from a multitude of disparate sources. In most organizations, data is scattered and is sometimes not managed properly, which complicates the process of preparing data for analytics. Data preparation is often a data analyst's least favorite task. It is estimated that 70% of the work in any analytic endeavor is spent getting your data report ready. The task of consuming and transforming data in Excel has long been one of the hardest, yet most important skills for a data analyst to master as they prepare data sets for consumption and presentation. This usually involves removing rows and columns, cleaning erroneous column values, enhancing data sets with new columns, and merging appending data sets. For years, Excel professionals have relied upon their mastery of advanced Excel functions such as VLOOKUP, if, find, clean, and substitute on top of traditional data import means. But recently, Microsoft has been working to modernize and up the end-to-end analytics experience inside of Excel. In this lesson, we will explore the capabilities of get and transform data. This functionality is often seen as a game changer for those that have used Excel for a long time. However, it does not mean that legacy cleaning methods go away. Some of the key features of get and transform data are the following. It has many data connectors available and more are being added periodically. You will see that the data gathering and shaping capabilities are fast, easy, and intuitive to use. And one of my favorite things are that the transformations are recorded, which allows you to repeat the steps to save manual and repetitive work. Plus, there are some excellent documentation features that we will cover. So what does this all add up to? It is often estimated that optimizing the repetitive activities around collecting, combining, and transforming data using Power Query and Excel will cut your data preparation time by up to 80%. In this lesson, we will cover the following. Will we use get and transform data? We'll load data from various sources, such as an Excel spreadsheet and from a website. We'll understand the data source settings, and we'll use the Power Creator to transform and cleanse data. Plus, we'll learn how to better manage get and transform data. Let's begin. Before we get going, let's quickly review the data lifecycle, then move into where get and transform data helps both the data consumer and data producer. In Excel, we may have a business process such as sales commissions that we're trying to calculate. Before we can go and calculate sales commissions, we would likely first need to get some sales data. So we would, as a data consumer, connect into a source that would provide us that sales data. Once that data is loaded into Excel, we may then act as a data producer to go ahead and calculate commissions based on that data. Once you've gone through the process of calculating commissions, we then may use the sales data and the commissions data downstream for reporting. So at that point, we may then act as a data consumer to consume both those sources and do some reporting. So how does all of this look inside of Excel? We can see on the diagram here that we're mapping out the data source to target locations inside of Excel. So starting on the far left-hand side of the diagram, we can see that like any organization, we have all kinds of different data sources. And we may wish to bring any number of these data sources into our Excel worksheets. So up above, we have the gray line that says get and transform data. So inside that suite of functions is where we can then perform what is called ETL. ETL stands for extract, transform, and load. Extract means extract the data from a source system that you were interested in. Transform is where you take that data and cleanse it, add to it, remove rows, remove columns, and get that data ready for whatever you're going to do with it. And then load basically is where do you actually want to load this data to? We're going to do all that work with the Power Query editor inside of Get and Transform at various parts of this lesson. Once data is loaded, we have a few places where we can actually choose to load it to. So we can choose to load data into native Excel structures, such as an Excel table, a pivot table report, or pivot chart, or we have the option to only create the connection to our source and the transformations that we have within that connection. We also have the ability to load data into the Excel data model, or what is also known as Power Pivot. So you may ask yourself, why would I make a decision to load to one versus the other? And if you want to load data to the Excel data model, one of the primary reasons that we do that is the Excel data model can handle more than native Excel can handle in terms of row capacity. Native Excel structures are limited to 1,048,576 rows, so just over 1 million rows worth of data. If you did need to load more data than that into Excel for your purposes, native Excel structures wouldn't work for you, and you may want to take a look at using the Excel data model. We won't be covering the Excel data model in this particular fundamentals course, but we wanted to ensure that we highlighted in this diagram for completeness purposes so that you get a sense for all the different places we could put things inside of Excel. To round out the diagram, we'll notice the gray line right above the native Excel blue bubble, and these are all the Excel functions which you've likely used for some period of time if you've been playing around with Excel. And the gray line right above the Excel data model is the language called DAX. which stands for data analysis expressions. It's the formula language that we use for the Excel data model. And once again, to recap, we're not going to actually do any coverage of the data model outside of this introduction in terms of showing it where it fits into the landscape of Excel. So now that we've gone over this high-level overview of how data moves from sources into individual target locations within Excel, let's go ahead and do a demonstration of this. So what I've got here is a blank Excel workbook, and we can see right now that we are on the Home tab. To get to the Get and Transform Data section, we are going to go over to the Data tab. So we'll click on the Data tab here. And now we'll see on the left-hand side here a group of functions called Get and Transform Data. What I'm going to do here is go to the Get Data button right here, click on that little drop-down box, and we're going to see there are a number of different sources that we can connect into. These are all grouped up by different source types. So I can get data from file types, so from Excel workbooks, CSV files, XML documents, JSON files, and you can read through the rest of the list. We can get data from databases, such as a SQL Server database, an Access database, and the list goes on there. We can get data from Azure sources, from online services, such as a SharePoint list, or from other services, which may include things like web pages or ODBC connections. So in this particular example, what we're going to do is we will go up to the file type here, and the first data type that we want to connect into is the text/CSV file type. So we'll click on that. We will see the Import Data dialog box pop up. And what we want to do here is we have a number of different data files which we can connect into. So I'm going to click on this sales territory one right here, which is a Excel CSV file. I'm going to then click this import button right here. And we will get presented with a preview of some information around this file. So we'll see this is the name of the file. It's a CSV file. It gives us a preview of the data and the columns. We can also see the file origination. We can see that it picked it up as a comma delimiter. And if we click on that box, we can see a number of other different delimiter types. This one chose the correct one. And then we can see data type detection. So what is happening here is the data types for each one of these 5 columns will be determined based on the first 200 rows in each one of those columns. Now, in my experience, this works really well for doing data type detections. But if you really wanted to, you could click this drop-down box here and ask it to base the data type detection on the entire data set. And just be forewarned, if you have a large data set, this may take some time. Or we may say, do not detect the data types. I will do this later on as the developer within the Power Query Editor. For now, we'll just leave it on the based as first 200 rows. And now what we want to do, now that we're satisfied with the file that we're connected into and how everything was all picked up by default, we can go down to the load button down below here and click this drop-down box next to the word load. And what this is going to allow us to do is ask us, where do we want to load our data to? So I'm going to click Load To, and we're presented with the Import Data dialog box. We can see that by default, it is choosing to load the data into a native Excel table. And down below here, it's asking us where do we want to put it, and it's choosing to put it onto a new worksheet. Alternatively, we could put that data into an existing worksheet if we wanted to. But in this example here, we're not actually going to physically load this data anywhere just yet. So let's go through the rest of the list. We could choose to load our data to a pivot table report. We could load it to a pivot chart, or we have the ability to only create the connection to the data itself. And this would include any transformations that we made to the data in the Power Query Editor. And at this point in time, have not done any yet. So we'll just choose only create connection. And you're going to notice that these boxes down here gray themselves out because we're not actually going to put the data in there yet. I do want to highlight this last checkbox here. It says add this data to the data model. So if you recall back to the data source to target locations diagram we talked about earlier on in this particular sublesson, we could choose to load this data to the Excel data model. If we wanted to do that, we would simply check that box and the data would then get put into the data model itself. We don't want to do this, so I'm going to uncheck that box. And at this point in time, we're ready to click OK. And what we're going to see here is now over in the query and connection pane here that we have a brand new query that has taken on the query name that was borrowed from the file name. And let's take a look at a few properties within this particular query. So if I click on this, we will see that we have got a preview. We can get a preview of the data within inside of Excel here. Oh, there we go. It says, here's the file name, here's the columns, and here's a sample of the data. We can see some other metadata based on this that says there's 5 columns with these names. It lets me know the data was last refreshed at this particular time. The data has not been loaded anywhere, and here's the actual data source. So one thing that I do want to do with this particular query is actually want to give it a good name. I'm really big on naming conventions and making sure that we choose good query names, and as we'll see later on, good column names, early on in the process so that we start promoting some maintainability of what we're building up. So I'm going to click on these 3 dots right here and go down to Properties, click on that. So I'm going to go ahead and give it a little bit nicer name and go ahead and click OK. And now we're going to see the query over here has been renamed to Sales Territories. So I do want to highlight that these are actually at this point in time called queries, because a query is just connecting into the source and performing the transformations on the data that you want to transform, but it is actually not loading into any physical structures at this point in time. So we can see here now that the proper name has been taken on and that we have the query set the way we want, and that then brings us to the end of sublesson number 1. In this particular sublesson, we are going to look at loading data from an Excel spreadsheet. And this is a very common source of data in many organizations. So let's begin. Okay, so I have my spreadsheet saved from my previous sublesson, and I can see that I'm on the Data tab here. And I want to go to my queries and connections. I want to see what queries and connections I currently have inside of this particular spreadsheet. So I'm going to click on this right here, and we're going to see that I have the sales territory. And if you completed the first sublesson, you will know that we were able to bring this one into the mix. So let's go ahead and bring another set of data into this particular sheet. So what I'm going to do is I'm going to go over to Get Data. I'm going to click the drop-down box here, and what I'm going to say is From File, and I'm going to choose from a workbook, like so. We will see that the Data Import dialog box is open here. So I can then go ahead and choose Sales. So I'm going to go ahead and choose this as my source, because right now I'm only looking at Excel sources. And I'm going to click on Import, and we'll let that dialog box come up. So what we'll see here is we have a navigator window that shows up that is giving us a preview into that Excel spreadsheet and the different objects that we can connect into using the Power Query Editor. So what I'm going to do here first is I'm going to click on this first object that says TBL Sales, and we will get a preview of what that data looks like inside of that structure. And then I'm going to click on this other object called SHT Sales and get a preview of the data. One difference that you will likely notice is when I clicked on SHT Sales is I get some extra data up above my data table, or what appears to be a data table. Whereas when I click on TBL Sales, I'm only seeing the data in the actual table itself. So let's explore why this is the case. What I'm going to do is I'm going to actually open up the source Excel spreadsheet and just show you what the navigator window here is seeing. So what this TBL Sales is and what SHT Sales is to explain it. So let's go ahead and open the source spreadsheet up. So as you can see, I have the source Excel spreadsheet open up now that I was just previously connecting into. And we can see that at the very bottom of the screen here, we have this thing here called SHT sales. So this is the sheet name, and that is bringing all the data in off of this sheet. So we can see we've got a title, and it looks like a subtitle here, plus all the data in here. If I go ahead and put my mouse inside of this structure right here and go up to the tabs, I can see that I'm actually inside an Excel table. And if I click on this table design, I can see there's a table there called TBL sales, which is all the data inside of this Excel table. So what is happening now is when we connect into this file, we can either connect into the sheet itself and all of its contents, or we can connect into the Excel table and its contents only. So what I'll do here is I just want to highlight that if I connect into SHT sales, so going over to the next one, I'm going to see that I will see this data here plus this blank row and then the data in the table. But when I connect into TBL sales, all I'm going to see is the Excel table itself. So a preference of mine is when I'm pulling data out of Excel spreadsheets that I like to see the data structured in an Excel table if it is all possible. It makes the import process a whole lot easier because we're only going to pull in the data that is related to the table versus having to clean up all the things in and around the table. But you may not have that choice. You may need to connect in the sheet and do that cleaning on your own inside of Power Query. It's not that bad, but like I say, I just prefer if I can connect into an Excel table. So let's go ahead and get back over into the spreadsheet that we're using to import data into and walk you through this process again. Okay, so we're back in the spreadsheet now where we are bringing our data into, and we can see now that I am connecting onto the object called TBL sales, and I'm only looking at the data inside of the Excel table. And once again, if I click on this SHT sales, I'm actually seeing the data that is inside the table plus the header information that we saw up above the table. So I'm going to choose TBL sales because that's what I want to connect into. And now let's go down to our load. And once again, I'm going to say load to. Wait for my import dialog box to show up. I'm going to say only create connection. I'm then going to click OK. And here we can see, once again, in the Queries and Connections pane, I can do a preview of the data within TBL sales, plus take a look at all the other metadata. So what are the columns? So I can see there's 14 columns here. Was last refreshed at 12:08. This data has been loaded nowhere, and here is the actual data source. So keeping in mind that I do want to make sure I have good naming conventions, let's go and rename this query. So I'm going to click on these three dots once again, go down to Properties, and here I'm just going to say Sales, click OK, and now I have my query here with a good name. That is the end of sublesson number 2. So far, we have seen how to load individual files into Get and Transform and through the Power Query Editor. But what if we have a number of files that all have the same structure? One approach would be to load each file individually, but over time that would start producing a bit of a maintenance challenge, because every time a brand new file came along that was of the same type, we would have to go into Power Query Editor and basically add in a brand new connection. Enter the folder data source. With this particular data source, we are able to put files that are of a similar type into a folder and have the folder data source treat all of those files as if they were one file. So this is fantastic when you have a scenario where you are continuously delivering files that all look the same structurally, but have different names, and maybe they're being delivered to you as the consumer on a periodic basis. We can simply write one set of transformations that apply to the folder, and then people can just, at their leisure, drop files that are compliant into the folder, and they will load directly into the actual target. And as I mentioned, this saves a tremendous amount of maintenance. So what does this look like? On the screen, I have an example here where I have a folder name and there's the name of the folder, plus a number of different files that exist inside of that folder, and they're of all of the exact same type. So we can see we've got 4 different files with their names. So we've got a product accessories, bikes, clothing, and components, and they're all Excel files. So all 4 of these files exist inside of one folder. So let's show you what that looks like. So here I can see that I have File Explorer opened to the folder name L02S05, and I see the 4 physical files located in the actual folder itself. So with the means you had previously learned, you may be tempted just to connect in each one of these files individually, and then if somebody added a brand new product type into this folder, you may go and create a connection directly into that and bring it into Power Query on a file-by-file basis. And as mentioned, that's going to be inefficient from a long-term maintenance perspective. So what we're going to do here is create a connection to this folder and treat these 4 files as if they were one. So to do this, we are going to go to the Data tab. We are going to click on Get Data, go to From File, and we're going to choose From Folder. The folder name dialog box appears, and I want to go and browse to where that folder is. So I'm going to click on the Browse button. I am going to go to the location where my folder is. So I'm just going to navigate to it here. So there's my folder, L02S05. Click OK. And now the path to that folder shows up in the dialog box. I'm going to click OK. All right, it looks like I found 4 files inside that folder with this extension. And if I just move this box over a little bit, these are the files that I would be looking at here. Plus a little bit of additional metadata about those files, which we're not concerned about at this point in time. So what I want to do next here is I'm going to go down to the bottom here under Combine, and I'm going to click the drop-down box next to it and say Combine and Transform Data. Give it a moment. And what is happening now is we get presented with a dialog box that is asking us how do we want to go about combining these files. So some of the rules that we'll keep in mind here, and we'll recap these in a few moments, is that first off, we need to choose a sample file. By default, it's the first file in the directory, so I'm just going to go here and just choose Product Accessories. I already know that all of these files follow the exact same structure, so they meet the rules that are necessary to be loaded, but I'll discuss what happens if they don't here momentarily. So what this means here is the sample file is the accessories file, and what will happen now is all other files have to look like product accessories from a structural perspective. So with that one being chosen as my sample, I go down here and say, well, where do I want to get data from that sample file? And as mentioned, I like choosing my data out of Excel tables. So I'm going to choose TBL product. Gives me a sample of what that looks like. And now what's going to happen is the other files that I bring into this particular transformation to follow this rule have to match the structure of product accessories. So there has to be a table, Excel table, in each one of them called TBL products. Otherwise, an error will occur. We'll discuss that in a second. And secondly, the column names that will be pulled in have to match what's in product accessories. So if any of the other files outside of product accessories have columns with different names, they will not be pulled in. It will only pull in the columns from the other files that match the column names of the product accessory files. Now, I know that sounds like a little bit of a mouthful, but we'll summarize these rules at the very end. So I'm going to choose TBL products. And the last thing I want to choose here is this button at the very bottom that says Skip Files with Error. So this little checkbox right here, if I click this, what will happen is the loading process will skip any files that don't structurally match product accessories. And it will do so silently, so it'll just skip over the file and load what it can that matches product accessories into this target model that you want to load and carry on. If I did not check that checkbox, what would happen is if any files inside of that directory did not match the structure of product accessories, the load would fail, and then we'd have to go in and correct things. So the results are extreme. Either it completely fails or it skips over the erroneous files silently, and you need to go and figure out how to fix that yourself. So I know that all of these files are of the same structure. So I'm just going to simply leave that unchecked, and I'll click OK. And what will happen now is I will get taken into the Power Query editor, because earlier on I chose combine and transform data. So now I'm sitting inside of the Power Query editor, and I can see where I got all of my data from. So I can see that I have my query named L02S05. So it took the name of the folder itself. So let's go ahead and rename this to something more appropriate. So this is a new location where we can go ahead and rename our queries. So I'm going to just call this products, like so. Just rename it to products. Let's get it spelled right, like that. Hit enter. And now we're going to see our query has been changed to products. I can also see here in my data preview pane is I have a little drop-down box in this column next to source.name, and here is where I can go in and take a look at all of the source files that are loaded in. So I can click on this, and it will show me that I got some information from product accessories, bikes, clothing, and components. So these are the 4 spreadsheets that were loaded in, and you'll notice all 4 of those spreadsheets were brought together and treated as if they're one, and they're loaded under the query name products. So now that I have completed that piece there, I can click this close and load. I can say the close and load to. So now I'm going to actually choose that option in a different spot. Remember, we did that in the import dialog box in the previous sublessons. So here I'm going to say close and load to, which is basically telling me to close the Power Query editor and load that data to a target location. So now I get back to my import data box. I'm going to choose the only create connection like I've been doing so far. I don't want to load this in the data model, and I'm going to click OK. So now we see over in our query and connections pane an additional folder which has some queries in here that are being used to help load that data from the 4 spreadsheets and treat them as if they're one. So I'm just going to close these folders up here. So I'm just going to go like this because I don't want to go ahead and play around with any of those, because that was created automatically for me through this transformation process. And now I can see I have this new query here called products, which once again has a column called source.name, showing me which one of the sources a particular row came from, plus all of the additional columns. So I can see there's 14 columns in here. Was last refreshed at 12:47. This data has not been loaded anywhere, and this is the source of the actual folder itself. So just to recap here, the folder data source is very useful when you want to go ahead and load a number of files that are of the same type and allow users to drop individual files into the folder. And as long as they're of the same type as the sample file we set up, it will just treat them as if they were all one file. So the rules are all the files have to have the same structure that has been declared in the sample file. That means the file types have to be the same. The columns all have to be the same. So the only columns that will get loaded from any other files that meet the structure are the ones that are in the sample files. And you do have the option to either skip the files with errors or let the entire load fail if any errors appear in the actual files themselves. And that brings an end to this sublesson on loading folder data sources. In this sublesson, we are going to look at loading data from a website. So we've shown you how to connect into a CSV file, an Excel spreadsheet, and then how to take advantage of the folder data type to save time and maintenance when loading files that are similar. As mentioned in this sublesson, we'll take a look at website data. So what we'll do is, once again, go to the Data tab. We'll go over to Get Data. We are going to go down to Other Sources and choose From Web. Go ahead and choose that. It's going to present us with a dialog box that asks us where do we want to get that information from. So I'm just going to paste in a URL pointing to the Federal Reserve to go ahead and connect into. So I'm just going to click OK. And we will get a dialog box that asks us a couple different questions. So it asks us, how do we want to go ahead and connect into this website? So I can connect as an anonymous user, and I can have those anonymous credentials apply at any one of these different levels. So starting at the actual HTML file we're taking a look at all the way down to the root of the website itself. I'm just going to leave it at that right there. Or I could go ahead and connect in using my current Windows credentials if they're valid. I can use basic authentication if I needed to log into the website, an API key if I needed to connect into some type of API, or some type of organizational account if I wanted to actually sign in using Microsoft 365, for example. In this example here, we're just going to go ahead and click Anonymous and choose Connect. And so it's going to take a moment here while it goes out to the Federal Reserve and looks at that website and sees what type of data can be connected into. So the navigator window is just churning its way through that website to see what is actually available. So we can see now that the navigator has shown us what is available on that website to connect into. So I can connect on this table here called Document, and I can see this is just a little bit of metadata about the actual website itself. And this thing down here called Table 0 is actually what we're going to want to connect into. So I can take a look at this and see that I have various dates and exchange rates. So what this data source is a history of US dollar to Canadian dollar foreign exchange rates since the year 2000. So this is what the table looks like in tabular view. I can also click on this web view here, and this is going to show me the piece of the website that we're actually going to connect into to extract that data out of. So we can confirm that's what we want. We'll go back to the table view here. And now what we're going to do is we're actually going to choose to load this data somewhere. So I'm going to go down to my load to, and I'm going to click on this load to right here. And now we'll get the import dialog box showing up. And this time, let's go ahead and put this data into the actual table to start with first. So previously, we've been doing only create connection across the board. Let's show you what this looks like when we actually deliver this into an Excel table. So I choose the table radio button. I'm going to click OK. Let it go ahead and connect into the actual website itself. And right now, it's making that connection, and it will load the data here. And we can see now that I get this Excel table of data, and I can tell it's an Excel table because with my cursor inside of the table, I get this table design tab showing up, and I can see that I have this thing here called table_0. So it's borrowing the object name from the navigator to connect into. Plus, it is also as the name of the query over here as indicated the same. So, and I did this to show you that we could load this out to an Excel table. But let's go ahead and remove this and get this set up so it's only created as a connection. So how we are going to go about doing that is we will go over to this Queries and Connections pane, and I'm going to right-click on the query itself, and I'm going to say Load To. And it's going to pop my Import Data dialog box back up. And now I'm going to choose Only Create Connections, so like I had done before. When I go ahead and click OK, it's letting me know that there's going to be a possible data loss, because what if I had brought this table in and started building some reporting on the other side of this table using it as a source? It's just warning me now that by switching that back, that data is now going to be gone. I don't care because I don't have anything built on top of that Excel table. Just go ahead and click OK. And we'll notice now the table disappears from over here, and it indicates now that only the connection has been created. Once again, I don't like this name that has been set up here. So what I'm going to do is I'm going to go down and right-click on Table 0, click on the properties. We'll get moved back over to here, and I'm just going to go ahead and call this USD to CAD FX, like so. Go ahead and click OK. So now my query has a brand new name, something that makes a little bit more sense. And once again, I can highlight over top of it and see some of the metadata about that particular query. And that brings an end to this sublesson on connecting to web data sources. Now that you've seen how to connect into a number of data sources, let's go ahead and review some of the other parts of get and transform data that we have yet to talk about. So let's go back over to our data tab. And under get and transform data, we're going to review a few different things. So we're going to go to get data first to start with. And what we're going to do is down at the bottom here, we can see that if we ever wanted to get back into the Power Query Editor, which we're going to use quite extensively in the next set of sublessons, we can click right here and it will take us into the Power Query Editor, and we're going to see the 4 queries that we have created so far. So that's if you want to get yourself back into the Power Query Editor. I'm just going to go ahead and click this X over here, and that closes us back out. If I wanted to go in and take a look at the different data source settings that we have accumulated so far, I can click on this data source settings, and I'm going to see that I have the 4 different sources that I've connected in to listed right here. So I can go through here and click on the sales territory one at the very top here. So this is showing the location of the sales territory CSV file that we had brought in an earlier sublesson. I can click this change source down at the very bottom here. And if I wanted to move that particular file around for some reason, I could go and move it and then just remap the location of that file right here. Also, if I wanted to, so I can go down to the next file, the sales one, and basically have the same thing. And we can go in and take a look at the permissions on these files. So I can click on Edit Permissions. We can see there are no permissions on this file. I'm just connecting directly into it. And I have this thing here called privacy levels for the individual files. So right now I have no privacy level set for any of these files, and we would have noticed that was the case on the previous one as well had we clicked on it. Or I can choose to make it a public file, an organizational level file, or a private file. So these privacy levels really just allow us to set a level on each one of these connections and potentially keep us from combining data sources that are not at an equivalent privacy level. Now, we're not going to dive any deeper into what privacy levels are all about here in this fundamentals class because the topic does get a little bit advanced, but just be aware that you do have the ability to control how you want to combine data sources together based on these different privacy levels. Okay, so then going down to the very last one here where we connected into the Federal Reserve data source, we can go over here and click on the Edit Permissions. And if you recall, when we set this one up back in the previous sublesson, that we went and set the credentials up to anonymous. So I'm just going to click on Edit here. And if for some reason we wanted to go back in and re-change those or make them Windows credentials or basic credentials or hook it to a web API, we could go ahead and reset those credentials here. And once again, this one also has the privacy levels being set. So each one of these different sources we can set a privacy level for. So let's go ahead and close that out. That's enough about our data source settings. And next what we're going to do is go ahead and review our recent sources. So what we can do here is let's click on the recent sources over here in the Get and Transform section. So if I click on this, it's going to show me the list of sources that I brought into the workbook over the last little bit here. So what I can do here is if I want to connect into a file for a second time, for example, and I don't want to have to go through and find the file and navigate to the file and things like that, I can just go in here, for example, and click on maybe a file I want to connect into again and click the connect button, and it's going to take me directly into that file. So it's just a way of shortcutting that initial get data and choosing the different sources you want to connect into, and then eventually getting to this dialog box. So we can go ahead and take advantage of that there if we want as well. Also in the recent sources, if I want, I can go and unpin these. So I can go ahead and remove these from the sources if I want. So I can just say connect to it again. I can copy the path of this item to the clipboard. I can keep it pinned to the list. I can remove it to the list. And if I want, I can say clear all these items that have not been pinned into my recent source because I want to keep them there right out of the list. I'm not going to go ahead and do that because I want to maybe keep these around here for subsequent use, but this is just a nice handy way to potentially reuse sources, again, without having to connect into things. And finally, let's explore the existing connections. So I'm going to click on existing connections here. And what I want to do is under this connections tab here is let's go down to the sales territory query itself. So here's where we can potentially go in and set some additional properties for the sales territory query. So I'm going to just go in here, choose on sales territory, right click and say edit connection properties. So in here there are a number of other properties that we can go ahead and set. We can set how the file is refreshed. So we can go through and say refresh every so many minutes. So if we want that query to refresh from its source periodically, we can go ahead and get that set up. We can ask the data to refresh when we open the file. We can control whether this connection is refreshed whenever we choose the refresh all option. And there's a number of other things we can do in here as well. We've got our definitions, which is going to show us where the file actually is and how it is actually being queried. And there's nothing of interest over here on this used in tab. Most of what we want to take a look in here is on this usage and primarily around this refreshing control. So let's go ahead and close that out. And that brings us to the end of the sub-lesson on the data source settings. Now that you have seen examples of how to connect into the vast array of data sources that are available in Excel, it is now time to shift attention to the different methods that are available to users to transform data using the Power Query Editor. So far, we've just connected into data sources, but we have not actually done a transformation of that data. So we've taken care of the E side of the ETL, but no transformations have yet occurred, nor have we loaded data to any target locations, aside from showing you how to load the foreign exchange rates into the table, which we did in a previous sub-lesson. It is generally a rare occasion where data that is made available to you is in the state you need it to be in for production quality reporting. If it is, count yourself lucky. If not, the Power Query Editor has a very rich set of features which allows users to perform transformation and cleansing activities with ease. You will often hear to this referred as data shaping, which has become the more modern term for extract, transform, and load, or ETL. So let's go in and take a look at the Power Query Editor and its components. So what I'm going to do is make sure I've got the Data tab highlighted like so. I am going to go over to Get Data, click on the drop-down box, and go to the Launch Power Query Editor. So the Power Query Editor will now open, and I can see the queries that I have loaded in so far to my spreadsheet. So let's take this opportunity to introduce you to the pieces of the Power Query Editor, which you're going to be spending quite a bit of time in over the next few sub-lessons. So what I'm going to do is I'm just going to go over on the left-hand side here under Queries, and I'm just going to choose Sales Territory. So I'm just going to click on it so that I get a number of other parts of the Power Query Editor opening up so that we can go ahead and walk our way through. First off, let's go ahead and take a look at the ribbon. So along the top, we have got our Home tab, which has a number of different transformational functions, which we will go ahead and take a look at shortly. We have the Transform tab, which once again has a number of different functions available to it, and we'll review those. The Add Column tab has a lot of the similar functions that are available on the previous two tabs. The difference here is with this particular tab, these functions will do the transformation, but add it as an extra column. So that is a very important thing to understand. So that is our ribbon. What we can then do is take a look at the queries pane. So down the left-hand side here, these are all the queries that we have built out so far. So some were generated automatically for us in earlier sub-lessons when we did the folder import. And in these other ones down here, these are the actual queries we had gone ahead and set up on our own. So we created the sales territory, which was connected into a CSV file, sales, which was in the Excel spreadsheet, products, which came from the folder of information, and then this USD to CAD foreign exchange came from our web data source. So those are the 4 queries that we have created so far. If we had created additional queries here, such as parameters, functions, lists, that would all show up down in the queries pane here on the left. At the very top of the screen, if I just go back up to sales territories, we will see that on my screen, I have a formula bar. So if you do not see the formula bar, the way to turn that on is to go to the View tab. And on the left under the Layout group, we will have the ability to click this formula bar checkbox, which turns it on and off. It is very useful to have the formula bar on because what is happening as we work our way through these sublessons, we will be performing transformations. And the code that is generated for us automatically through these transformation steps is all written in a language called M, which is automatically done for us. And a great way to learn any language is to actually watch how it is being used and being generated. So to start with, I like to encourage people to leave the formula bar on so that you can watch what is being generated and kind of learn from the code that is being worked on. Now, as a general rule, when you are getting into using Power Query Editor, you're not going to really need to learn the M language that is underneath. But over time, as you start bringing more and more complex data sources in and become a little bit more confident with the actual interface itself, you may wish to start venturing down the path of learning the M language and the code that is being generated underneath the covers here. And we'll summarize this at the very last sublesson when we go and show you how all the code was brought together. So that's the formula bar. Over on the far right-hand side, we have our queries settings pane. So we have the name of the query we're working with. And in a couple of previous lessons, we have changed those query names in a couple spots. And then further down below are all the different applied steps that we're applying to that query as we take a copy of the data from our source and eventually perform transformations on it to be delivered out to our target sources. So we will spend quite a bit of time showing you the applied steps. And once again, at the very end, after we've done quite a bit of work in the actual sublessons, we'll show you the aggregate of all this and how we can better manage these applied steps. And finally, in the middle, we have our data preview pane. So if we want to take a look at what the data looks like at the current transformation step, which is in the applied steps right here, this is what the data would look like just before it gets delivered out to our target sources, should we actually have any target sources chosen. So this is the data preview pane. At the very bottom of the screen is some more metadata around the actual queries that are being brought in. So we can see here that I've got 5 columns in this query. There's 10 rows. And it's letting me know the column profiling is being based on the top 1,000 rows. So a little bit more metadata about that. So now over here on the right-hand side, you'll notice that we have some preview information about when the information was last downloaded. So we can see that I last downloaded this information at 11:57 a.m. So that's just a little bit of extra metadata on it. So that is an overview of the Power Query Editor, and we're going to be working with it quite a few over the next few sublessons. That brings an end to this sublesson. One of the first things we encourage people to do when bringing data in from a source system is to only bring the data that you need. So that means removing columns and filtering rows. In this particular sublesson, we are going to look at removing columns of information. So there are a few different ways to go about performing this particular task. So let's begin. Okay, so the first thing we're going to do is we're going to go in and choose the columns that we want to actually go and remove from our data source. So your first temptation may be to do something along these lines. So let's say that we didn't want the due date and we didn't want the ship date and purchase order and a couple of other columns that are through here, which we'll go ahead and pick en masse. So if we want to choose multiple columns to get rid of, what we can do is highlight on the column. So click on the column name so it turns green like this, and we can see it. And then click the control key down and start choosing the columns that you no longer want to see as part of your data set. So due date, ship date. I'm going to get rid of the purchase order number. I'm going to get rid of the account number. Scrolling over a little bit more, I am going to go ahead and get rid of the store number. I'm going to get rid of person full name. I'm going to go ahead and get rid of this national ID. I'm going to leave our product number. I'm going to get rid of this order total and leave unit price and order quantity. So the only columns I really want to see are the order quantity, unit price, the product number, sales territory, the order status and type, which I have right here, and then my order date. So what I'm going to do here is I'm just going to go ahead and go to my home tab and go to the columns, manage columns group right here, and click on this remove columns. And I'm just going to say remove columns. And just like that, we'll see an additional step was added into my applied steps called remove columns. And now you can see that I only have the columns that I wanted to keep. So the ones that I did not highlight back in the previous step. So this may be your first temptation when wanting to go ahead and getting rid of columns, but this isn't necessarily the best way of doing things. Because what you've done here is you basically said, I want to get rid of these columns. And you've gone through and declared the columns that you want to get rid of. But what happens now with this data source if suddenly a new column is added back at source? And you actually don't want that in your final data set. Well, the problem is that new column will show up at source, come into our query now, and it will actually be included in this list because we didn't explicitly remove it. Now, we may be able to go back into Power Query and remove it at a later date, but we don't necessarily want that type of maintainability challenges built into our queries. So what we're going to do here is I'm actually going to get rid of this step right here. So I'm going to go to this remove columns that I had right here, and I'm just going to delete this step. Go ahead and do that. And now our data is back at the state it was when we first started this exercise. So now we'll show you the preferred way of actually doing the removal of columns. What we're going to do is we're going to tell the query editor the columns we want to keep and say remove the other columns. So what we're going to do here is we are going to first do it the way you may be tempted to do it, and I'm going to show you a more efficient way of doing it, is I could go in here if I know I want to keep the order date, and I'm going to hit the control key, and I'm going to keep the order status and type. I know that I also want to keep the sales territory right here. I also want to keep the product number. I also want the unit price and order quantity. So I'm just clicking the control, and these are the columns that I want to keep. So with that, what I can do is I'm just going to scroll to the left. I'm going to go to the remove columns, and I'm going to say remove other columns. So what that's doing is saying I want to keep these columns and get rid of all the other ones. The nice thing about this methodology here is, going back to the example we used at the beginning, is if a data source actually had a new column added to it and it worked its way into Power Query, this methodology is going to keep it from actually flowing into your target. So that's a much nicer way of doing things and will save you on the maintenance. Now, using the control key and clicking away through all the columns was not so bad, but let's show you an even better way of doing things. So once again, I'm going to go ahead and get rid of that removed other column step. And this time, I'm going to go under Manage Columns and click Choose Columns. So I go to Choose Columns, and I'll pull up a dialog box, which is a whole lot easier to navigate than shuffling back and forth between all of the columns in the data preview pane. And in this case here, what I'm going to do is I'm just going to turn off all the columns and now only select the ones that I want. So now I want order date, order status and type. I want the sales territory, the unit price, the order quantity. Oh, and I forgot the product number. So I want that one as well. So I go ahead like that. And now I've got a list that I can go through and choose ones I want. One added benefit of this particular methodology of doing things. If I have a really long list of columns in a source, and I've worked with a lot of spreadsheets that have a lot of data and a lot of columns in them, I can actually use this search functionality to go and find those particular columns I want to take a look at. Also, over here on the right-hand side before we finish up, if I can click this, and I can have this list sorted in natural order name, which means the order that the columns were presented to me in source. So that's basically what we see in behind here in the preview pane. Or I can actually go ahead and order this list by name. So if I knew what column names I wanted to keep, I could put it in alphabetic order and then sift my way through the list much easier that way. This list was really small, so I was able to just go on the screen and choose the ones I want. But the salient point here is you have a lot of different ways that you can go in and find the columns you want to keep. So I'm just going to go ahead and click OK. And the net result of this is I have the exact same remove other column step that I had back in the previous step. This time I went through and actually used that dialog box. If I wanted, I could go back. So let's just say I want to go back and edit that list. Right next to this edit or remove other columns, I can click this little gear, and it's going to bring me right back to this choose column. So in this step, I could go through and add and remove columns as I saw fit. Okay, so let's just go ahead and cancel that out. And that is it. So just a few different ways to go through and remove the columns that you want, a couple different techniques. I do like to show you the hard way of doing things and then how to progressively make things easier, because that's the way I find most people do their learning when they're starting to work with Power Query. All right, so that brings us to the end of this sublesson. As mentioned in a previous sublesson, some of the first things we want to do when connecting into a data source is to ensure that we remove the columns we do not need and filter the rows that are not needed as well. So let's go ahead and take a look at this data source, which we're going to bring into our spreadsheet, and show you how this is going to work. So we can see that this is a CSV file, and it looks like it's a report. It's got some header information at the top, a blank row here, and even within the data set itself, there are these blank rows, which we want to get rid of here. So we're just going to show you those right there. So we got blank there, there, and there. And at the very end, we have some blank rows that we're going to want to deal with as well. So unlike hooking into an Excel table, which has some structure to it, this CSV file is going to be a little less structured. We're going to have to do some cleanup of the actual data as we're bringing it through into the Power Query editor. So let's go ahead and get into the Power Query editor and ingest this file and show you how we're going to take advantage of the features of row filtering to clean this data set up. So I am back over in my Excel spreadsheet now, and so now I want to make a connection into the file that I was just showing you. So I'm going to go to the Data tab. I'm going to go to Get Data. I'm going to say From File, from text/CSV, and I want to connect in this one called Product Finished Goods right here. And it's going to click Import. And we can see, like we did before, we can see a preview what the data looks like, the file origin, the delimiter, and then how Power Query Editor is doing its data type detection. And we can once again take a look at this to verify that yes, this is the file that we did want to bring in. So previously we had been clicking on load and load to and just getting a connection set up and leaving our file at that. So we're just doing the E side of the ETL. Now we actually want to start doing some transformations. So we will go ahead and click this Transform Data button, which is going to take us into the actual Power Query Editor so we can pick up from the E side of the ETL and start doing some transformations. So we can see the contents of the file that we previously showed you here in the data preview pane. And now we want to go ahead and use the remove rows functionality to clean this file up. So the first thing we're going to do is we know that we want to get rid of the top 3 rows by the looks of it, and it looks like we probably want to get rid of the bottom 3 rows as well. So let's go into remove rows and click on this, and let's say remove top, and the dialog box will pop up, and we're going to say top 3. Go ahead and click OK, and now the top 3 rows disappear. We can once again go back to reduce rows and click remove bottom rows, so the next one down, and we also want to remove the bottom 3 there as well. and now the bottom 3 rows are gone. Next thing we want to do is we want to get rid of these blank rows. So we got blanks in these few rows going all the way across all the column values. So what we can do is choose remove rows and say remove blank rows. So now the data set is further reduced. Next, what we can do is we see that in row number 1, it appears that these are the column headers. So let's go ahead and move over the Transform tab over here. And under the table group, we can go ahead and click Use First Rows Headers. And suddenly our data looks like that. So we've done quite a few steps here. So let's go through and review what has happened in our applied steps now. So if we go right to the very top and click on Source, this will show us the source file that we actually connected into. So if I take a look in my formula bar up here, I can click on this and it looks like it's connecting into the CSV file. Once again, I mentioned earlier, you don't need to know this M code, but it's really nice to look at so that you can understand what is being generated as you go through each one of the steps in the Power Query editor. So let's close that back up. All right, so that's step number 1. The next thing that happens is that the data types are chosen. Those 2 steps are performed automatically. Then we got into the steps where we started doing some work. So here's where we removed the top 3 rows, then the bottom 3 rows, got rid of the blank rows, promoted to headers, and then this step was automatically included or inserted by the Power Query editor, and it went through and did the data type changes once again. So our data set is now looking fairly clean. So let's go ahead and do some further cleansing of this. Now, if we take a closer look at the data set, we're going to see that we have some duplication in our data set. So if we take a look at rows 4, 5, and 6 here, that we can see the same product number repeats itself across these 3 rows. Now, if we take a look across all the column values, in fact, these 3 rows aren't duplicates because they do have differing values across the columns. So I can see in the color column that this very first one, row 4, is black and then red and then blue. So if we take a look at deduplication across all the column values, 4, 5, and 6 are actually not duplicates. But if we only take a look at the product number itself, these are declared as duplicates. Right below it in rows 7 and 8, we can see that there's a product number that repeats itself. And if we looked across all the columns, and I'm not going to scroll all the way to the right-hand side, these values are actually duplicates across all the column values. So we have a couple different ways of dealing with these duplicates, and it's very important to understand the differences between the two. So I'm going to go back to my Home tab, and I'm going to go back over to Remove Rows, and keep in mind here right now that I'm highlighted on the product number column. So I'm going to run my deduplication process on the product number column only. So I'm going to go to Remove Rows and say Remove Duplicates. And what you're going to notice here is we're going to go down from 16 rows to 13, and we'll explain in a moment. So we can see a brand new step was added into Applied Steps called Remove Duplicates. And we can see now that we only have one instance of this row right here, so the 2908, and one instance of 2036. And that deduplication process works fine if we want to do our deduplication on this particular column here only. But to me, that is a little problematic given this data set because, as shown earlier, the 2908 rows, those 3 aren't actually duplicates. We consider their values across all the columns. So what I'm going to do here is I'm going to get rid of this applied step. So that is one of the really nice things about the applied steps here is I can actually get rid of them as I build them up. So I'm going to go like that. And now my data set is back to the 16 rows. So it's worthwhile highlighting at this point here that in Power Query, you're just taking a copy of the data from your source. You're not actually modifying the source information. So as we go back across each one of these applied steps like we did a moment ago, where we just click through the individual steps, this is a copy of the data and showing us what each one of the steps look like after it is performed and what the data set then looks like. So what we're going to do now is we want to do the deduplication across all the column values. So I'm going to click on product number, go Control A to select the entire table. I'm going to go over to Remove Rows and now choose Remove Duplicates again. So now I should be knocked down to 15 rows because these 2908 rows, they are declared to be different because their column values are not the same across all 3 of those rows. So they stay, and only this 2036 row remains. Okay, so like I say, that's a really important thing to distinguish in terms of how the deduplication process is running, and you certainly don't want that one to catch you off guard, so it's worthwhile highlighting the differences there. And that brings us to the end of this sublesson. Often when we get a data source or connect to a data source, the column names and data types are not quite what we would like them to be. In this sublesson here, we're going to talk about fixing up column names and setting appropriate data types. So I am right now highlighted on the products query in Power Query Editor, and I can go across in my data preview pane and see that there's a number of columns here that don't really have very good names on them. So I've got this column here called pnum, which looks like it's probably some type of product number, pname, which is some type of product name, and then I've got a number of other columns here that don't have any spaces between the words. And that can be a little bit problematic when it comes to end user reporting or consuming things later on. So you just want to make sure you're making good choices for your names. So let's go ahead first and rename these columns right here. So what we can do, there's a few different ways of doing this, is I can double click on the column itself and it will turn blue, so I can do the rename. I could right click on it, and down near the bottom there's a rename function here, which basically is the same thing. Now the column turns blue. And at this point I can go and rename this column. So I'm going to call this product number, like so. And the next one, I want to go ahead and change this to product name. So I'm just going to go like this and say product name, like so, and hit enter. So now I've got these columns lined up the way that I want. And let's suppose now that I also wanted to maybe just add some spaces into this finished goods flag. So I can just double click inside of the column, and in between each of these words here I can go finished goods flag, like so. That just makes it a little bit friendlier for our end users. So the next thing we want to do here, and I'll just show you how to do the column renaming on those first three there, because once you learn how to do column renaming, it's the same across all the different columns you may want to do, so there's no point watching me redo 14 or rename 14 different columns in this data source. So the next thing we want to do is let's go ahead and make sure that each one of these columns has the proper data type. So I'm going to just go through each one of these columns one by one, and we'll actually do this here. I can see that this first one here is a text data type. The product number is a text data type, and the way I can tell that is this ABC right here. So if I click on that little box right there, I can take a look at the data types and actually change them if I want to right here. And I can go down here and see that ABC, that symbol, indicates this as a text. If I wanted to change it to any one of these other ones, I could, as long as it was a valid conversion. So going through the rest of the columns here, product name is set up as a text. That's great. The finished goods flag is set up as a whole number. So if I click on that, I can see that as a whole number, which I'm fine with. Going across to color, that's text, which we're good with. We start growing a little further across here, so whole number. Then we move into these columns here that are our cost values. So what I'm going to do here is I'm just going to click on this data type symbol right here, and I can see this is set up as a decimal number. But what if I want to go ahead and make this a currency? So I can go ahead and click currency, and now I can see that this now is rendered as 2 decimal places. I can go over to list price and do the exact same thing to make sure its data type gets set the way I want. Go across. We're good with text. That is fine. That is fine. Then we get to this column right here, which is a start sell date. So when do we actually start selling this product? And it looks like this actually set itself up as a text value for some reason, but we want to actually make this a date. So what we can do is click on this here and go down to date. And now we can see this converts itself into a date. One of the reasons that setting the data type is so important is that a lot of the downstream transformations you may want to apply to your data will be dependent on the type of data that is chosen. So I can see here that when I clicked on this start sell date 2, which I just turned to a date, now I get these date filters that are showing up like so, where I can actually do filtering based on the actual date itself. So it gives me a whole lot of different options. If I go right next to the one next to it here, I can click on this category name, which is ABC123. I click the drop-down box next to it, and now I've got filters that are for text-based values. So with that, making sure that right off the bat, as you are getting your things brought into Power Query Editor, you do a few things very quickly. Number one is, as we've talked about previously, is remove columns you don't need. Number two is remove or filter the rows you don't want your data sets as well. Number three is making sure you get your column names set to names that make sense to you. And number four is making sure you get the proper data type set up, because you're going to live with the names and the data types all the way through the rest of the transformations you do, and ultimately out to whatever your target is that you're delivering your data to, and users will then have to use it there as well. Okay, that is it, and that brings us to the end of this sublesson. Quite frequently, when bringing data in from sources, you may not have all the columns of information that you want for one reason or another. In this sublesson, we will talk about adding new columns to our query. So the first one we're going to do here is I am highlighted on my sales query here. And if I just scroll a little bit to the right, we're going to notice I have a column here for a unit price and another column for order quantity. We may want a third column here that is a calculation of the unit price and the order quantity multiplied together to create a brand new column. So let's go ahead and do that. So the easiest way to do this is to go and find the two columns that you want to multiply together, and go ahead and click on the unit price, hit the control key, and click the order quantity here. So with these two columns chosen, I can go to my Add Column tab and go over to the From Number group here and click on Standard, and I can click on this Multiply here. So if I click Multiply, we're going to notice that a brand new column gets added and is called Multiplication, which if we take a look at the M code here, it appears that it's going through and multiplying the unit price in the order quantity and creating as a new data type, which has the type of a number. So if I go down here and take a look at this, it added this new step in called Inserted Multiplication. And as we previously learned in our previous sublesson, we can go through and rename this column. So let's just call this line total. So I'm just going to go and rename it and say line total like so. And now I have my additional column added into here. All right, so now let's go over to the products query here. So we can see that if I just take a look at the data preview, we've got this product number. And if I take a look at the very beginning of every one of my product numbers, there's the first two characters there are indicating something. So it looks like it's some type of product category or something along those lines. But what I want to do is I'm going to add a brand new column and just take the value of the first two characters out of the product number. So let's go ahead and do that. What I want to do is, once again, make sure that the product number is highlighted like so. And I can go up to the Add Column tab, and under the From Text group, I can click on Extract. And maybe I say I want to extract the first character. So I'm going to choose this. And the dialog box is then going to ask me how many characters do I want to extract. And I'm going to keep the first two. So I'm going to go like this, click OK. And now a brand new column called First Characters gets added with the first two characters of each one of the product numbers. So once again, I'm just going to go ahead and rename this, and I'm just going to call this Product Code or something like that. So let's give it a name like this. Okay, so now we have our product code that we've created. And finally, let's go and add a brand new column into our product finished goods. So if you recall, that was this one right here the one that is still using the cryptic name of the file that was brought in. So what I want to do is let's go and rename this query here. So let's go and call this product finished goods. So I'm just going to go to with this query highlighted, go over to the query settings, and I'm just going to remove this first piece out here and just call this product finished goods, like so. And now what we want to do is we want to go ahead and add a brand new column into our query here called finished goods flag. So let's go ahead and do that. And what I want to do here now is go up into my Add Columns tab, and under General, I'm going to click on this one here called Custom Column. So I'm going to click on Custom Column, like so. And my new column name, I am going to call this Finished Goods Flag. So Finished Goods Flag, like so, with the spaces. And the value I want to put in here is I want to leave the equal sign, and I'm just going to put a 0. And now what is going to happen is I'm going to get a brand new column added to this called Finished Good Flags, which is going to be 0 all the way across the board. So I go ahead and click OK. And now I get this new column. So one of the other things what just happened here is now the data type for this particular column is the ABC123 data type, which means the any data type. So I want to actually go through here and make sure we give this a proper data type. So I'm going to go through and we're just going to choose whole number because we want it to match to the data type of the finished good flags in the other product query, because eventually we're going to take these and append them together. So I'm just going to go whole number, and now we'll notice that this data type has been changed to a whole number. So we showed you a couple different ways to add some brand new columns with a static value like this here. One where we are extracting some values from a previous column, and then one where we're doing some basic math on a couple existing columns. That brings us to the end of this sublesson. Sometimes when getting data from sources, data can be spread across many different source systems. And we ultimately want to bring all that data together and append it into one table. What we're going to talk about in this sublesson is how we can take multiple different queries, which may be coming from different sources, and get them appended into one data set. So for example, on the screen here, we have two queries, query 1 and query 2, and we can see that each query has 4 columns, but if we really take a good look at the query names, there's actually differences between the column names within those queries. So we can see in query 1, we've got a column called product number with no space between the word product and number. And in query 2, we've got a column called product number, but there's a space between product and number. So that's important because that will basically indicate that those are actually 2 different columns. So to the human eye, we may look at those and say, oh, those should line up to be the exact same column. But when it comes to how the appending works, they're seen as 2 different columns because their names are different. We take a look at the name column and the product name column. Once again, 2 different column names. So they're going to be appended into 2 separate columns. We'll notice that finished good flags exists only in query 1, but not query 2. The color exists in both, and it has the exact same name. So those 2 are going to line up nicely. And supplier only comes from query 2, and there's no value for a column called supplier in query number 1. So what happens is if we want to append these 2 queries together like so, the final result will look something like this. Well, we'll end up with this third query, which has a column called product number, which comes from query number 1, a column called name, which its values will come from column number 1, and the values down here are blank because there are no values in query number 2 for a column called name or product number with no space. We'll see the finished goods flag comes from query number 1 only. Color actually comes from both, so we can see that actually appends together properly. And then the columns that didn't line up right were the product number with the space shows up down here. The product name with the space is here, and the supplier, which only exists in query 2, shows up down here. So if we wanted these to line up properly, one of the first things to do before you do your appending is make sure you go through and standardize the names between the queries you want to append so that when it lines them up properly. Because ultimately what we would want to see happen if the names are right is these values would actually be sitting over here like so. And then things would line up nicely. That's not the case, so they were over here, and that just means that we need to go ahead and clean our queries up. So let's go and show you an example of this using the real data set we have. So I'm going to go back over to Get Data and go into my Power Query Editor. So I'll click on that. What I'm going to do here first is I'm going to click on my products query, because I want to append products and product finished goods together. And I want to do this as a brand new query, much like I illustrated back on the previous slide. So under the Home tab with Combine Group, under the Combine Group here, I can click on Append Queries. I'm going to say Append Queries is new, so I'm going to create a brand new query, which is an appended version of those two queries. The primary table is products, because that's the one I was highlighted on when I kicked this dialog off, or this process. And then the next I can say the tables to append to the primary table are my product finished goods. So I'm going to append these two queries together, and we're going to get a brand new query called Append1 showing up here. And this one I would want to rename, which we'll do momentarily here. And we can see now that our columns lined up. So I had the product number with a space in both, so within the products query and in the product finished goods. So these lined up nicely. So these would have all shown up in the product number column. I made sure the same standardization was in place for product name. The finished good flags, once again, was standardized across both. And if I go all the way over to the end here, we'll see that all of the columns actually lined up properly, aside from the fact that the first characters one, because if you recall back in a previous sub-lesson, we took the first two characters in the product query and pulled them out. So we're going to see that the first characters are showing up in some, and they're in null in the other ones. And when they're null, these are the ones that came from the query for product finished goods, because product finished goods did not have a column called first character, so it had no idea what to do and just put null into that column. So now what we have is this brand new query called Append1. We'd want to go ahead and rename this, and we could go ahead and just call this product list or something like that. And this is essentially the list of the complete products. So bringing the finished good products and the products query, which we had pulled in a little bit earlier using the folder connection type. And now we have a complete set of product information. So let's go ahead and enter, let that query take, and that is it. That brings us to the end of this sublesson. Another technique that is available for combining datasets is the merge queries. Merging queries is used when you want to bring columns of data from one dataset over into another. For example, what you see on the screen is two queries, query 1 and query 2. What we would like to do is get the name column from query number 2 and bring it into query number 1. As you'll notice, query number 1 has a column called product number, but there is no product name. If we would like to bring those into the exact same data set, we could use the merge queries functionality. If you were using native Excel functions, this is where you may look to use the VLOOKUP or XLOOKUP. Merging queries is a much more flexible way to actually bring these two data sets together, because we have the ability to actually join on multiple columns. In this case, we only really need to join on one, which is the product number. So if we actually merge these two data sets together on product number, we would have a final result that looks something like this. In this case, we take the two queries, merge them together, and we would end up with the product name in this brand new query. So we would have our order date from query number 1, sales territory from query number 1, product number from query number 1. Technically, product number can come from either one of query 1 or query 2, so we only want to choose one of them. In this example, we chose query 1. We take the unit price from query 1, the order quantity from query 1, the color comes from query number 2, and so does the name. So now we have this new query here, which is a combination of queries 1 and 2. And there's two different ways to do this, which we'll show you here in a moment, to get this complete data set. So let's move into an example of this using the data that we have. I will go ahead and open up the Power Query Editor. And what we want to do is we want to take the sales information. So let's take a look at the sales query. And we can see in here that there is a product number, but there is no product name or even product subcategories or categories. So what we're going to look to do is bring the product subcategory and category from the product list, because we can see if we just scroll over here a little bit that we have a product subcategory and category over here as well as the product name, and we're going to bring those three columns over into the sales query. So we're going to do that by clicking on the sales query, and on the Home tab, if we just go over a little bit to the right, we're going to see a group here called Combine. What we'll do next is click on Merge Queries, and we have two options. So we can say Merge the Queries. If we choose Merge Queries with the sales query highlighted like I have on the screen here, what we'll end up doing is take the columns from the second query, which we'll choose here in a moment, and merge them into this query. I could choose Merge Queries as New, which could bring the sales and the product list together, which is the one we'll merge in here, and it would create a brand new query with the columns from those two columns or those two tables that we actually choose. So in this case, we're just going to say Merge Queries. Given we were highlighted on the sales table, it becomes our parent table. And the table that I want to merge into this is the product list. So we'll choose product list. And now what we need to do is choose the column that we want to use to match between the two queries. So in this case, it's product number in the sales table and product number over in our product list. So what we can see here is that we are performing a join. It's letting me know that the 46,646 rows that are in the sales table all can find a match over in the product list table. So what I'm going to do here now is I'm going to click OK. And now what ends up happening is I have an additional column that is sitting on the very back of the sales query, and it is in the form of a table. So what we're going to do here is click these column expanders and open that up. And now what we're going to do is we get the option to choose the columns we want to bring from the product list into the sales table. So what I'm going to do here is I'm just going to click Select All to get rid of all the columns. I'm going to uncheck this Use Original Column Name as Prefix, like so. And the three columns I actually want to bring into my sales query are the product name, subcategory name, and category name. Go ahead and click OK. And we'll see now that we have the product number, and at the very end of the table, we have the three columns which we just brought from the product list table. So product name, subcategory name, and category name. So some additional things to know about the merge queries. If I just go back up to the step here where we did the merging and clicked the gear sign right here and take a look at how we did this merge, it is important that the columns that we're actually using to merge actually have the same data type. So product number here and product number here, the column names do not matter, but the data type does. And also, as mentioned, we can actually join on multiple columns. So if I wanted to, let's just hypothetically say that the order quantity was related to this finished good flags, but they're not. I could hit the Control key, click on order quantity, and then click on finished goods flags if these two are related. And what we're going to notice here is we get some subscripts next to each one of these columns. So that's letting us know that the number 1 right here next to product number matches to this one here, and the number 2 next to order quantity matches this one here. So we can start adding multiple columns to this particular relationship. I don't want to do that because these columns are not technically columns we would want to merge on. So I'm just going to go ahead and turn those off and get the merge set back to product number across each one of the tables. Go ahead and cancel out of there again. And we can now see, as mentioned, we have the exact result that we want. So I just wanted to go back and explain the ability to merge on multiple columns and the fact that the data types have to match and the column name does not matter when we're doing the merging. Although it is a best practice to make sure that we do get the column names matching before we go through that particular exercise, because that's just something, as we mentioned back in some of the previous sub-lessons, we just want to standardize our names and get them set as early as possible, because we will be constantly using those names throughout all of our work through Power Query Editor and into the actual source data itself. And that brings an end to this sub-lesson. So far, we have talked a lot about connecting into data sources and bringing them into the Power Query Editor. And we've done a little bit of work with merging data sets and appending data sets. But what about actually doing some cleansing of the data? In this sublesson, we will take a look at just that. What we'll take a look at first here is our product list. So if we take a look at our product list query, like I have here, and I click on the product name, I can see a bunch of dirty data. So it looks like I have some spaces in the front of the product name here. I likely have some spaces on the very back as well. Looks like this one column here called cable lock actually maybe has some type of carriage return line feeding it because it's split it off into two lines here. So we may want to look at cleaning that. And we look at some of the standardization issues between some of these column values as well. If we take a look at column number 2, this looks like it is, or sorry, row number 2, it looks like it's all uppercase. And this one here looks like it's all lowercase. And down here looks like we have some that are initial case and then lowercase after that. So let's go and look at how to actually clean that data. So what I'm going to do here is my product name is highlighted. What I want to do is go to my Transform tab. And if I go over to the text column group right here, and I choose Format, I have a number of different things I can do to clean this data up. So what I'm going to do here first is I want to actually go through and clean all the row values in here first. And what the clean function is going to do is get rid of any non-printable characters that are showing up in those values. So as I pointed out a moment ago, the column number, so the row number 5 there that has the cable lock in it, looks like it must have some type of carriage return line feed in it. So if I go clean and go like that, we're going to see that those characters got removed from there. So now cable lock is all on one line. Okay, so that's one clean that we can do. Now how about we look to get rid of this white space that is in front of these strings and any potential white space that may be on the back. So to do that, let's also go to the Format function here, and we'll click on that. We're going to say Trim. And what Trim is going to do is get rid of white space at the front and very back of this string value. And lastly, to standardize this column here, we can stay on product name, we can go to Format, and we can say capitalize each word so that we now have a standard look and feel across all the rows in this particular column. We're doing a lot of this here just to make that column value look a little bit more professional when somebody wants to go and use that for input somewhere down the line, or if you're going to use this in analytics, it has a nice look and feel when it comes to your reporting layer. So that is one type of clean there that we want to do. Something that I should point out is keep in mind here that we applied the steps there to clean up this particular column in the product list query. We could have done it in the products query or the product finished goods query. The only challenge with that is if we did it there, we would have to run all 3 of those cleaning steps in those queries individually. By putting it into the appended product list query, we're able to do those transformations once. So what we're going to look at next here is if I go back to my product list and just scroll over and find our product category and product subcategories, we are going to find out that there are some row values here that do not have a value for subcategory name and category name. And those all happen to come from the query called product finished goods. Because if you keep in mind here, product finished goods did not have a column called subcategory name or category name. So what ended up happening when those values got appended together in the product list is they ended up with a null value. So what we're going to do here is we're going to go and clean that up by finding our subcategory name and category name columns. And I'm going to click on these both together here. And this time I'm going to right click and I'm going to go in here and choose replace values. And what I'm going to do here now is the value I want to find is the null. And I want to replace this with a value. I'm going to say other, like so. So that works really nice if I want to have the value for null across both of these replaced with the exact same value. So that works really well, like I mentioned, if you want to have them replaced with the same value. But what if you want each one of these to have a different value? What we would need to do is actually go into each of these columns individually to perform that. So let's go back and get rid of this applied step. And part of this reason I took you down this path here is I want to show you that have the ability to get rid of previous steps. So let's go ahead and get rid of that replacement there where I took the null across each one of these two columns and replaced with the word other. And let's go and do these individually. So I'm going to right click. I'm going to come down here and say replace values. And I'm going to say null because we have the null value which we're trying to replace. And what I'm going to say here is other subcategory this time. So we'll go ahead and get that typed out like so. And just to save myself a bit of time, I'm going to copy that there. So I'm going to say OK. And what we'll notice here now is if I click on this right here, we will scroll down here and we're going to find a new category called other subcategory. I go over and do the exact same thing right here. So I'm just going to go click on that, save replace values. I'm going to choose the null and just my time saver here. I'm going to do that and I'm going to say other category like so. Go ahead and click OK. And now any of the column values that were null are going to come up with this new label of other category. Typically, the reason that we go ahead and replace null values with something more meaningful is that, I guess the opposite of what I was just saying, is the null value is a confusing value for people to look at. It is a little odd to look at the reporting layer. And if we replace it with another value, it is a little bit easier to go ahead and consume at the reporting layer and lets the users know that it falls into some other type of category. And this is really just all part of cleansing your data sets so that they look clean and consistent to your potential consumers or even other producers of information. Okay, so that is some cleaning that we did on those two columns, and it's going to go ahead and cancel there. So the subcategory name and category name have been taken care of. So now let's go over to our sales table. So I'm going to move over to the sales query here. And what we're going to notice here first is we have this column that has two different values in it. It looks like it has an order status and a type all embedded into one column. But what if we wanted to separate order status into its own column and the type of order into its own column? So take this and go ahead and separate these apart. To do that, we are going to go in and split this column apart. So what I'll do here is I'm going to highlight on order status and type. I go to the transform tab, and over here in the text column group, I can see this function here called split column. And what I'm going to do here is I'm going to go in and say split column by delimiter. And the delimiter that we are going to split the column on is the comma. So it went and chose the space. Let's go ahead and choose the comma as the split. And we are going to do it at the leftmost. If we left it at each occurrence, the delimiter would work because there's only one occurrence in each one of the columns. And go like so, click OK. We will notice now that we have a brand new column called order status and type .1, which has the value shipped in it. And if we go over here, we're going to see a brand new column. Oh, sorry, my apologies, was right beside it. So we can see order, status, and type 2 right next to it here. So they were split into their own columns. So what I'm going to do here now is I'm just going to actually go through and rename these. So the engine wasn't smart enough to give them proper names. It just called them the original name .1 and .2. So I'm just going to go ahead and double click on there, and let's just call this one order status. And this one right here, what we're going to do is we're just going to leave this one and call it order type. So I'm just going to leave type like this, hit enter, and now I have that split off into 2 columns on their own. Now we do want to be aware that if we remember what the data looked like before we did this split, so I'm just going to go back over here and click on the expanded product list to go one above where we did the split, we're going to see that it had a comma and then a space and then online order. So what has happened is, given that we split on that comma there, there's actually a white space in front of online order. So we want to go ahead and get rid of that. So I'm going to go back down to this step right here where we rename the columns. And like we had done a moment ago, I'm just going to right click on this and I'm going to go down to transform. So I'm going to get at this trimming from a different location. So as opposed to up on the transform tab, I'm going to go transform and I'm going to say trim. And that is going to get rid of the white space in front of that particular row value across that column there. So the trim will actually get rid of the white space as mentioned earlier, the front and the back of that particular string. So we have seen a few different ways to transform and cleanse your data. We went through and cleaned up a particular column. We did some replacing of values across a column. Then we took a look at splitting data. And those are some major things that we typically do when it comes to transforming and cleaning data. So that brings an end to this sublesson. Occasionally, we get data from people that isn't structured into traditional rows and columns. Sometimes when we ask for information, it comes in pivoted form. As you can see on the screen here, I have somebody's budgeted product sales by year and month in spreadsheet form, and they've already got all the data pivoted out so that we have, just to show you here up at the top of the screen, we have 2019, which should go across all these values. Here's the months, and then each one of these intersection points is the budget for that particular month within 2019. So we can see for accessories, 2019 January, we have no budget. For accessories, February 2019, we have no budget as well. And for the rest of the year. Aside from December, so December we can see has a accessories budget for December 2019 of 106, and the 2019 total is 106 as well. What we're going to do to take this particular data set and get it put in traditional rows and columns is use what is called the Unpivot functionality that is available in Power Query Editor. And what that is going to do is basically what I had just described when I was showing each one of these intersection points, is take each one of these cells here inside of the Excel spreadsheet, well, I guess at this point it's an Excel, is it takes each one of these cells here and each cell will turn into a row with the values of accessories, no value, a month of January in 2019. Accessories, no value for February 2019. And if I go down to bikes, we'll have values of bikes, $252 being the value, January being the month, and 2019 being the year. So what it amounts to is each one of these intersection points right here. So every cell inside of this particular table will end up as a different row. And then we're going to have to go through and do some cleaning of that data set to actually get this into rows and columns, plus a cleansed set of rows and columns. So we only have values for all of this right here. And we can clean out all these totals that are sitting here and make sure that we repeat these values all the way across. So let's go ahead and do that. So back in my spreadsheet that I'm using to consume data into, I'm going to go to the Get Data functionality. I am going to go over to this file and choose Workbook and go ahead and find where the book happens to be. So I navigate to this particular location right here, and I'm choosing this file here called Pivot Examples. I'm going to click on Import and let the window go ahead and take a look. And here I can see I've got my sheet called Budget Data. So instead of pulling it out of a table this time, I'm actually pulling it off of the sheet. And if I scroll through here, I can see that, yeah, this looks like the data I had back in that spreadsheet, because I can see a year and then the months and the categories repeating themselves here along with the grand total, and then all the different cell values right here. So what we're going to do is go ahead and use the Unpivot functionality plus a few other cleansing features to go ahead and get this into a cleansed set of columns and rows. To do this, we will click Transform Data because we want to get into the Power Creator to do some cleansing. We'll let the data set go ahead and pop up. And the first thing we want to do here is we want to take this the header information right here, we want to push it down into a row value. To do that, we are going to go to the Transform tab. We're going to go to the table grouping here, and where it says Use First Row as Header, we're going to click on this and say Use Headers as First Row. So we're going to go ahead and push this down one level, like so. And the next thing we're going to do here is we want to get rid of the rows that are blank. So we have nulls across all of these columns here. So we're going to use a function that we used before. We're going to go up into our Home tab. We're going to go into Remove Rows, and we're going to say Remove Blank Rows. So go ahead and do that. And that got rid of all of our blank rows. Next, what I want to do is I actually want to get rid of this very first row. So keep in mind, this is the one I pushed out of the headers a moment ago, and now I want to get rid of that. So I'm going to go Remove Rows and say Remove Top Rows, and I'm going to go ahead and just choose my top one row like so. Go ahead and click OK. And at this point, I'm ready to go and transpose this table of data. I do that by going to the Transform tab up here, and I click Transpose. And what that's going to do is flip the data set around. So I'm just basically going to twist the data set, and I end up with something along these lines here. Next, what I'm going to do is I'm going to push this row right here into my header. So I'm going to click on the Use First Rows Headers like so. Click that, and it will move those up into the headers. And what I want to do now is I want to go and change the data type of column number 1. So right now, this data type is the any data type because Power Creator is not really too sure what to do with this data type. We want to go ahead and turn this into a text data type. And the reason we want to do this is, let me just show you before we go ahead and do it, is if I click this and want to do some filtering of data, my filtering is very limited when Power Query does not know the data type. I can have an equals and does not equal. But what you'll notice here in a moment here is if I go over here and just cancel that out and click on that and choose the data type to be text and now go over to my drop-down box and filter, I have a whole range of different filtering that I can do to that data there. But before I do anything with that, let's go ahead and take advantage of the fill function because we know that we want this 2019 to repeat itself down across all of these rows here. So wherever these nulls are, we know that this is January 2019, this is February 2019, March 2019. When we took a look at that on the original source spreadsheet, it was implied by the way that the report was set up that 2019 was to repeat itself across all of the particular columns back at source. But now we want to actually make it repeat through the rows. So what we're going to do here is we're going to go to the Transform tab under the Any Column grouping, go to Fill, and we're going to say Fill Down. And what we're going to notice now is that 2019 repeats itself all the way till it hits the first valid value, and 2020 is going to repeat itself all the way down as well. So the next piece of cleansing we can do is we don't want these columns in here that have the word total at the very end, because we can go ahead and compute those totals later on. We don't actually want these in our data set. They can be a confusing piece of things. So what we're going to do is we will click on the drop-down box here, and we're going to go to the text filters, and we're not going to go over here to text filters and say, whoops, and say does not contain. And what we want to do here is we are going to type in total. And we're going to do this in the correct case because the Power Query language, the M language, is case sensitive by default. If I go ahead and say does not contain total, click OK, we're going to notice now that all of those total rows disappeared out of our data set. So our data set is now actually starting to look pretty good. The next thing we want to do here is the column here that is now called column number 1, or has been called column number 1 for a little bit here. Let's go ahead and rename this. We want to go ahead and call this year. So we're just going to double click on this and say year. Oops, let's spell it properly. And over in here, we're going to call this one month, like so. And after that renaming is done, what we can do here is we are going to go and twist this data set so that we end up with what are called attribute value pairs. So each one of these intersection points right here, so this null and accessories will be a row, this will be its own row, its own row, its own row. So right here, this first row here is going to generate 4 rows, and what we'll end up doing is generating 4 rows by 24. So that is going to be just under 100 rows, doing my math really quickly here, approximating things. And that's going to turn these all into a number of rows. So what we're going to do is turn and click on the year and click on the month columns. And what I'm going to do is go up into my transform tab here. And what I'm going to do here is go over to the any column group once again and click on unpivot columns. And what I'm going to do here is click this unpivot other columns. And what it's going to do now is take our data set and twist it into attribute and value pairs. So keep in mind here that I mentioned that we would end up with a number of rows for each one of the values we had back in the previous data set. So let's go ahead and take a look at what that looks like here in a sec. So we can see the data set has been pivoted, but what seems unusual if we take a look in the bottom part of the screen here is it says there are 4 columns and 74 rows. And we said just a moment ago that we should have just under 100 rows, because if we go back a step here and we see that we had 4 different columns here and there's 24 rows, that should take us to 96 different rows that should come across after we did this unpivot. And we only ended up with 74. What ended up happening is each one of these values here, if I just go back to my previous step that had a null value in it, is discarded from the data set. So if we count these, we would see that we had 22 new rows that we formed that had a null value in it, and those would get excluded from the data set. So if I go back over here, I have the 74 rows, and that's basically the explanation in behind that. So the next thing we can do here now is go ahead and we can see these rows here that say grand total in them. So what I want to do is I'm going to go ahead and filter those out. So I'm just going to click this drop down box and say text filters. And once again, I'm going to go in here and say does not contain, and let's go here and type grand total. Like so. Go ahead and click OK. And now the grand total rows have been removed out of the data set. The last thing we need to do here now is let's give these attribute value pairs a proper name. And this right here is called product category. So we'll just go product and type category, like so. And over here in this other column, we want to actually call this, let's call this budget amount, because this was a budgeted amount. So budget amount, like so. And now we have essentially taken our data set that was in a report form and actually twisted it into traditional rows and columns. The last change I would probably want to make here is this budget amount. Instead of having it be a whole numbers, let's go ahead and put this into a currency value like so that we have our values looking like that. And all the other data types look just fine. All right, so that is a pretty quick look through how to take a data set and unpivot it from its pivoted form. And even though that seemed like an awful lot of steps and may have seemed a little strange in terms of how we actually how we did that, this pattern will repeat itself over and over again as you start doing unpivoting data sets like this. So you're going to find that the way that you do this is similar across data sets that look like this. So right off the hop in the lesson introduction, I mentioned that there are some very interesting features inside of Power Query that really allow you to organize your queries and document them effectively right within the tool. So let's go ahead and take a look at some of the things we can do to really improve the long-term maintainability of what we've built out. So I'm going to go back into my Power Query editor. So I'm going to go over to Get Data and say Launch Power Query Editor. We'll get back into the editor itself, and we can see down the left-hand side that we have a number of queries we've built up. And keep in mind, so far we've only built 7 different queries up, but as you do work with Power Query Editor, you could find yourself getting a lot of queries. So what we might want to do here is we may want to group up our queries into different categories of queries. So what I'm going to do here is I'm just going to show you the ability to go ahead and group these. And I'm going to go ahead and right click in a blank space here over in the queries pane and say new group. And what new group is going to do is give me a brand new folder for putting my queries in. So what I'm going to do here is I'm going to say, I'm going to call this one dimensions, like so. And that's going to create me a brand new group. And I am going to go into here and say new group. And what I'm going to do is I'm going to call this facts. So don't worry about what facts and dimensions are. Just take these as 2 different folders that I can use to group my queries into. So what I'm going to do here is I'm going to take my budget data. And what I can do is I can right click on it and say move to group facts. So I can go ahead and do that. Or I could do drag and drop. So I can take, let's go ahead and do the sales one next. I'm going to take sales and drop it up here. So now sales is in the facts section. What I may want to do now is take my sales territories, products, this conversion rate, and maybe my product list and the product finished goods. And let's go ahead and move that up into the dimensions group like so. So we can see now I've got 5 of the queries sitting here inside of dimensions, and for some reason it looks like the sales one slipped out, so let's go ahead and put that one back over to facts. So I have 5 different dimension queries and 2 facts here. I cannot get rid of this other queries area here. This is the default group within Power Query Editor, so I can't get rid of that, so I'm just going to leave that one alone. And any brand new queries I create will automatically go into here until I move them into a different area. So the salient point here is you have the ability to start grouping up your queries and making them easier to go ahead and find and just promote some general organization. The next thing that we want to do is we want to go in and make sure we've given our queries good names. So in this case here, I'm just going to choose budget data. So I could go here and if I like the name of this query, which I actually don't mind, I'm going to leave it alone. But I can right click on the query itself and go down to properties down below here, and I can take a look at the name, and maybe I just want to put a space in here, so I want to call it budget space data, or maybe I want to get rid of the word data completely and just call it budget sales, or maybe sales budget, something along those lines. So let's go like that, call it sales budget. And what we can do down here in the description is add some commentary about maybe where we got this information from. So we can say, got this file from Bob in finance. And this way, if somebody else comes to pick up this Power Query from me and they want to know where did all these queries come from and who provided the source, I've got some information in here. Now I'd probably go and describe this a little bit better, but I just want to put enough in here to show you what the description is all about. So click OK. And we're now going to see that the query name is changed to sales budget. And if I hover over top of it, the tooltip is saying got this file from Bob in finance. And maybe since I was naming queries like this, I want to go through and rename this one to sales actuals. like so. And then I can differentiate between the fact that I've got some sales information and some budget information. Okay, so in the spirit of naming our objects properly and giving them descriptions, we can go and do the same over in our applied steps. So right here, if you recall back when we took a look at our sales query, we went and added in a brand new column, and it took the unit price times the order quantity, and it gave it a default name called inserted multiplication, which doesn't really mean a lot. What if we wanted to give that something a little bit more meaningful from a naming perspective? So we can right click on that and say properties. And in here we can say, calculated, what is this, line total, something like that. This way, when we take a look at this line, it makes a little bit more sense. And we could also put a description here. So we can just say used the business rule from finance or something like that. So lots of finance touches inside of this file, like so. And this really is a business rule anybody could figure out. But once again, just showing you put some descriptions in here. Go ahead and click OK. And now we can see that the applied step has been renamed, so it makes more sense now. If I ever wanted to go find out where was the calculation for line total, it actually is a little bit more apparent. And once again, if I highlight over top of this, I can see that the commentary for that comes up as well. So we use the rule from finance. So once again, I could go through and rename all of these steps. I could give them descriptions. There's not really a lot of point doing that right now across all these, because once I show you the technique for doing one, you can go ahead and apply that to all the ones you want in whatever you have from a production capacity. What we want to show you next here now is, let's go up to the top here in the View tab. So I click on the View tab, and what I want to show you here next is this thing called Query Dependency. So if I go ahead and click on this, it will pull up a dependency tree and just make this a little bit larger. And I do realize I have to scroll or zoom in here a little bit. So let's go like this. And now what we see is a pictorial here. If I just make this a smidge bigger, this shows me how all of my data is being pulled from their sources and landing in the Power Query Editor and all the different steps the data is going through. So what I can see here is if I take a look at my sales actuals, for example, so if I click on this one right here, I see that it turns green, and I can see that it came originally from the folder here called Lesson 2 Data Files L02 S05. So keeping in mind that we got some of the product information when we were doing the merging together from here. So all of that got built over here and eventually was built into a products list. And then that product list was merged into sales actuals because we wanted to get the product name, the subcategory, and category into it. And then the actual sales information came from this Excel spreadsheet here called sales.xlsx. So we can go through and see the way that everything was all built out. If I want to take a look at the way the sales budget was built, I click on that, and we can see that it came from the spreadsheet that was called Pivot Examples. And then even the commentary that we put into the query itself shows up here as well. So I can see that we got this from Bob in Finance. So this is a really nice way to show you how all your data starts off and all the different steps it goes through from a step-by-step perspective so that you can get a bit of a picture as to how all these queries depend on each other. So what we'll do next here is let's go ahead and close this off. And the last thing I want to show you is we mentioned that a while back in a couple of the sub-lessons that the language that underpins the Power Query Editor is a language called M. And at no point during this these sub-lessons we've gone through have we actually written any M code. But it all has been generated through the steps that went through when we did all the work in the Power Query Editor. So if we want to take a look at the aggregate of all the steps that were used for a particular query, we can do it a couple different ways. So I can click on each one of these applied steps. So I'm on the sales actuals query, and I can click on source, and I take a look in here, and it shows me where this information came from. So this is a piece of M code. Go down to the navigation, and we see another piece of M code. Go down here, and then M code, M code, M code. So each one of these steps forms its own line of code. If I want to take a look at it all together, I can click on this advanced editor right next to query dependencies, and this will pull up all the M code that was used from start to finish to take our data file for sales actuals and actually load it in and get it all cleansed to the final state. So as mentioned before, this is the M language. When you're starting off with using the Power Query Editor, I don't necessarily recommend you get in and play a lot with the M language. There's probably not really a lot of need in most cases to do so, but do go ahead and turn the formula bar on so you can watch the M code that is being generated as you're doing your work, because it is a good way to learn the language. As you start progressing your skills in Power Query Editor, you will find a time where understanding the M language can actually save you a lot of time and make you a more efficient developer in the Power Query space. So let's go ahead and close that off. Get that closed out here. And that pretty much concludes the things that I want to show you for making your Power Query more maintainable and showing you some of the features and functions that make it easier for you to pick your files up months down the line, or for you to hand them over to a different person and have them understand how you built all of your stuff up. All right, that brings an end to this sublesson.
Before we start preparing data for our analysis and reports, it is important to review some relevant Excel concepts related to structuring and referencing our data within Excel. These skills will enhance our productivity within Excel and will assist in developing more efficient, reliable, sustainable, and reusable Excel models. During this lesson, we will review the two cell reference styles for Excel, discuss the importance of absolute and relative cell reference types, learn how to better manage cell references using named ranges, review Excel tables, and the use of structured references to access their data within formulas. We will highlight the difference between formulas and functions, and discuss options to check function compatibility across various Excel versions. Next, we will examine the newly introduced dynamic array capability within Excel for Microsoft 365 and the use of implicit intersection behavior with dynamic arrays. Finally, we will incorporate the concepts learned in this lesson into a relatively simple data analysis solution. For your convenience, these topics are listed as individual sublessons so you can easily navigate or skip as per your comfort level. So let's begin. Although you should be able to follow the course content with either style, you can easily revert to your preferred cell reference style using the following menu option. Go under File, Options, Formulas, and then look for the R1C1 reference style option under the Working with Formulas section. When developing Excel-based solutions, quite often you will be copying, moving, or filling formulas to other cells within Excel. Irrespective of your preferred cell reference style, you will thus be required to incorporate relative or absolute cell references within your formulas. Excel cell references are relative by default, which means when you copy a formula from a cell to another cell, the row or column references including within it will be updated relative to the formula cell. Now in this example, if we wanted to sum the values in column 1 and column 2 for each row in these columns, we can use the sum function and then select the values in a row and then press enter. We can then select the formula we just typed in and copy that into another cell in the same column, or we can use the fill handle to copy down the formula into other cells in the same column. Now if we use the Ctrl+tilde shortcut, we can see that Excel has automatically updated the row references in each formula that was copied down the sum column. This is made possible by the relative cell reference capability within Excel. Now carrying on with the same example, if we copy the formula from a cell in the sum column to another cell in the same row of the all sum column,
Using the Ctrl+tilde keyboard shortcut again, we see that Excel has automatically updated the column reference from K to N in the new formula. This again is made possible by the default relative cell reference functionality within Excel. However, in some cases, this behavior might not be desirable. For example, if we had to sum the values for column 1 and column 2 into the sum column, and the values from column 1 and alternate column 2 into the alternate sum column, we would want that our reference for column K is not updated as we move it into the alternate sum column. To achieve this, we use the absolute cell referencing capability within Excel. When writing formulas with absolute cell references, we lock a part of or the entire cell reference to a specific row, column, or cell. We achieve this by using the $sign prefix for the part of the reference that we do not want to change. So in our case, that would be the column K reference in the original formula. Now adding the $sign prefix, pressing enter, and then copying the formula down into other cells, we can see that the row references in these formulas have been updated as desired. However, the column K reference has stayed the same. Now copying the same formula into the alternate sum column, and then using the Ctrl+tilde shortcut, we can now see that the column K reference has not been updated as was done previously. We would expect to see the same result when copying this formula into other cells of the alternate sum column. So to summarize, we typically use a combination of relative and absolute cell reference types to author formulas that we expect to copy across multiple cells while maintaining a reference to a specific cell, a specific row, or a specific column. This allows us to optimize our design process and expedite model development by writing fewer formulas that can update reliably when copied, moved, or filled across the expected data structures within our models. When building complex Excel models with various inputs, outputs, and transitionary data, it often gets cumbersome to track and maintain explicit cell references that we reviewed in the previous sublesson. To avoid such challenges, Excel provides a few ways to structure and manage our data references. We can use named ranges for individual cells or an array of cells, which would typically be referenced using absolute cell references. For example, input variables to a complex calculation, or maybe a list of values for a drop-down selection. For scenarios where we have tabular data sets that may need to be referenced for lookups, calculations, etc., we typically use structured references within Excel tables. And finally, with the latest releases for Microsoft 365, dynamic arrays and the corresponding spill reference notation have been made available for more advanced reference capabilities. During this sublesson, we will review Excel capabilities related to creating, using, updating, and reviewing named ranges. We will discuss the other two topics later in this course. Using our previous example for relative and absolute cell references, we will now create a conditional sum column where we will sum the values in column 1 with values in column 2 or the alternate column 2 based on a selection we make in cell I6. I have entered the corresponding formula using explicit cell references here. Note how we have used a mix of absolute and relative cell references to achieve our desired results. The specific reference we will focus on for this example is cell I6. Note how we have prefixed the $sign for both the column and row reference. This will make sure that this reference is not updated as we copy this formula down the conditional sum column or potentially into another column. We will now remove the tilde at the start of this formula and press enter to review the result. We can then copy this formula into the other cells in this column and confirm that the results match the values in the appropriate column based on the current selection. We can also modify our selection to confirm that the implemented logic works as expected. Now, typically such variables will be located on an input sheet within our models, and we will define names for them. This will allow us to easily reference them within formulas throughout the model. In our case, we will just use the name box to enter the name as displayed in the header for cell I6. We can then revise the formula in our conditional sum column to use the new name that we just defined. We can also copy the formula into the other cells within this column and confirm that the results have not changed. Finally, we can modify our selection again and confirm that the results still update as expected. Now, in case we have already written some formulas with explicit cell references and would like to update them with new names that we have defined, we will select the cells with the explicit cell references, navigate to the Formulas tab, click on the arrow next to the Define button, and click on the Apply Names button. We will then select the names that we want to apply, and then click OK. Entering any cell in the range we just edited, we can confirm that where applicable, our explicit cell references have now been updated with the names we just selected. Also note that by using appropriate names, our formulas are now much more readable when compared to their explicit cell reference versions. Using names thus allows us to author efficient and consistent formulas that are easy to review and support. When using names in our models, at some point we want to review or edit the defined names, or maybe we need to change the cells or ranges these defined names refer to. For this activity, we can use the Named Manager under the Formulas tab. Using this dialog box, we can create new names by clicking on the New button, and then providing our desired name, the scope for this name, a comment for future reference, and the cell or range this name refers to. Similarly, we can edit or delete existing names using the corresponding buttons within the dialog box. This dialog box also provides the option to filter the names within this workbook by scope, error status, or by type. Most Excel models utilize tabular data, which is typically structured using built-in Excel tables. This is probably one of the most powerful Excel capabilities for data analysis. Organizing our data within an Excel table provides several inherent capabilities. We will review some of them during this sublesson. To start with, let's create an Excel table using this data set. To do that, we select the data range, and then select one of the Format as Table options under the Home tab of the ribbon bar. Alternatively, we can use the Ctrl+T keyboard shortcut, and then confirm if our table range has headers, and then click OK. Once created, the Excel table allows for more efficient formatting, data entry, and updates. Several quick formatting options are available under the Table Design tab in the ribbon bar. Here, we can customize the look and feel for the entire table, or for specific rows and columns within the table. To add data to this Excel table, we can simply type in the new values in the first row after the table, or we can add the new value in the last cell and then press the Tab key. The last cell is typically the lower right cell of the table. For inserting new rows between existing rows, we can right-click anywhere in the table and use one of the options under the Insert menu. Similarly, we can add new columns for our tables as well. If we want to remove data from our table, we can either select a row and delete it from the worksheet, or we can right-click in a row within the table and select an option from the Delete Context menu. However, in some cases, other adjoining data on the worksheet might prevent us from using one of the above methods to add or delete data from our Excel table. It is thus important that we plan around such constraints when designing our data structures and model layout. As an example, since we have other data within this row, we will not be able to delete the entire row from the worksheet. Similarly, since there is another table with more columns below our data table here, Excel will not allow us to delete a row from our data table using the context menu option. In these cases, we may be able to move some of our data within the table to overwrite the rows that we want to delete, and then use the sizing handle for our table to resize the table layout. We can also temporarily move our data table to another location which does not have any adjoining data, make the required changes, and then move it back to the original location. However, it is usually best to plan for such constraints when designing our table layouts and other data structures within our models. We can use a similar process for deleting columns from our data tables as well. Once we have structured our Excel table and have captured the required data within it, we can leverage some of its other capabilities that are extremely useful within a data analysis context. Apart from the quick style and formatting options that we highlighted earlier, when working with larger data sets, an important and often ignored benefit of Excel tables is the support for various task and navigation shortcuts. These shortcuts immensely improve our productivity when entering, navigating, or reviewing data within our tables. Now let's review some of these options. Upon selecting any cell within the table, we can use the key combination Ctrl+A to select all data within the table. We can press Ctrl+A a second time to select the headers and total rows in addition to the data rows. We can also use the Ctrl+arrow keys to navigate to the start or end of a continuous data segment within our table. And pressing Shift with this key combination allows us to select the same data as we navigate through it. In some cases, we might want to ignore the gaps within our data and select the entire row or column. As you can see in column 1, by using the Ctrl, Shift, and down arrow key, it only selects the first 2 rows in the column. If we wanted to select the entire column, we can use the Ctrl+Space keyboard shortcut, which ignores any gaps within the dataset. We can use a similar shortcut with Shift+Spacebar, which selects the entire row, ignoring any gaps within the data. These shortcuts will also work if we had multiple rows or columns selected. So in this case, if we select the first 2 rows in the table and use the shortcut Shift+Space, it will span the selection across both those rows. As we enter data within a table, we can also use the Alt+down arrow key to display other text values entered within the current column. This feature can assist with easy and consistent data entry. Please note that this shortcut ignores any numeric values within the current column, including dates and booleans. Using the key combination Ctrl, Shift, and plus sign, we can also add a row or column next to our current cell. If we select 2 cells in the same row and use the key combination Ctrl, Shift, and plus, it will add another row above the currently selected cells. Similarly, if we select 2 cells within the same column and use the same key combination, Ctrl, Shift, and plus, it will enter a new column to the left of the currently selected cells. We can delete rows or columns using a similar key combination, Ctrl and minus sign. All Excel tables by default are created with a header row. All column headers in this row are pre-configured for sort and filter capabilities. As we scroll through larger data sets or other content on the worksheet, the headers for our data table are visible at the top of each column, if the currently selected cell is within the Excel table. If we select a cell outside the data table, the Excel column headers revert back to the regular column references. We can optionally add a total row at the bottom of our table by selecting the cell immediately below the column we want to aggregate, and then selecting the Auto Sum option from the Editing group on the Home menu tab. This row can also be added or removed from the Table Styles option under the Table Design menu tab. Once added, we can change the aggregation function using the drop-down list for any cell within the total row. New aggregations can also be added using the same drop-down list. Quite often, we will also need to create calculated columns within our tables. These are created by entering a formula within any cell of the table and then pressing Enter. If there is no other data within the column, or if it is already a calculated column, the newly entered formula is autofilled for all cells within the edited column, without the need to manually copy or fill it across other cells. We can use undo immediately after such autofill for scenarios where this behavior might not be desired. When writing formulas within or outside our Excel tables, we can easily reference data within the tables by using dynamic cell ranges that are automatically created and named for each table and its columns. These cell ranges, referring to different parts of an Excel table, are referred to as structured references and expand automatically when new data is added to the table. Structured references allow formulas to be read, understood, and maintained much more efficiently than explicit cell references, and in some cases even define names. In Microsoft 365 Excel, these references exhibit spill behavior and can be used with the implicit intersection operator. We will discuss these concepts in more detail later in this lesson. For now, let's look at some of the structured references provided with Excel tables. Structured references for Excel tables have a consistent syntax. The table name is followed by either a column specifier to reference a specific column, an item specifier to reference a specific portion of the table, or a table specifier to reference a specific part of an item specifier. Furthermore, all these specifiers need to be enclosed within square brackets. Now let's look at some of these in action. If we wanted to reference the entire table, including the column headers, data, and totals, we will use the All Item specifier for the table. As we enter the formula, you can see the table data spill into the columns and rows starting from the formula cell. This is made possible by the spill behavior within Excel 365. We will discuss this in further detail later on in this lesson. Similarly, if we wanted to reference only the headers for this table, we will use the headers item specifier and the totals item specifier for the total row. For referencing the data portion of this table, we could either use the data item specifier or simply type in the name of the table and press Enter. For referencing the data values within a specific column, we will use the corresponding column specifier. If we wanted to get all values in column 2, including the column headers, data, and totals, we will create a table specifier with the All Item specifier and a column 2 outer reference. As mentioned earlier, structured references can also be combined with the implicit intersection operator. Although this topic will be discussed in further detail later in this course, it basically retrieves the values from the reference data in the same row as the formula cell. So in this specific case, it's retrieving the values from the ET table, table 1, from column 2, in the same row as this formula cell. This can be validated once we compare the retrieved value with all values in column 2 for the previous structured reference we reviewed. The implicit intersection operator can also be used to retrieve all values in the table within this row of the Excel worksheet. Similarly, we can use the this row item specifier to retrieve all values in the Excel table on this specific worksheet row. So as you can see, structured references provide a variety of ways to dynamically access data within Excel tables. This helps immensely when developing complex Excel models using tabular datasets. Another benefit of Excel tables is the ability to easily summarize, filter, or display your data using pivot tables, dynamic charts, slicers, timelines, and more. Some of these capabilities will be discussed during later lessons in this course. With Excel tables, we can also leverage other advanced capabilities within Excel, like Power Query, relationships, and data model. However, these capabilities are not within the scope of this course and may be covered within other intermediate or advanced Excel courses. Formulas and functions are core to performing calculations, analyzing data, and solving problems within Excel. At this point, we will highlight some differences between the two. We will also discuss some ways to access useful information regarding Excel functions and check for compatibility when building Excel models that might be used in different versions. Let's look at formulas first. Formulas are expressions used to calculate the value of a cell. Typically, these expressions may use one or more of the following: constants, explicit cell references, defined names, structured cell references, and/or built-in Excel functions. Let's review some examples of these expressions. For this first example, we have an expression with a constant value of 5 as entered in cell C3. Next, we have an expression that uses explicit cell references to add 6 to the value of cell C3. Removing the tilde from the front of the formula, we can see the value once we press enter. For the next example, we use a defined name from lesson 3 to generate a conditional value. In the next example, we use structured references to get the value from column 1 in table ET-TBL table 1 from the same row as the currently selected cell. And finally, we use the built-in max function to get the maximum value from the numbers listed above. Excel functions, as used in our last example, are predefined formulas that are already available to use within Excel. Excel also provides the ability to write user-defined functions. However, these are not within the scope of this course. When developing solutions within Excel, quite often we will need to review the descriptions, usage, and compatibility constraints for the Excel functions. As a data analyst, we might even be required to build solutions that are compatible with our client's version of Excel, which might be different from our version. When working with Excel, we can have convenient access to such information from right within the application window. When authoring formulas, we can access the Excel functions available within our version of Excel under the Functions Library group within the Formulas tab of the ribbon bar. We may sometimes want to review additional information about these functions to understand their usage or review the required arguments and maybe some example use cases for additional clarity. Depending upon your preference, you can use one of the following options to look up such information. To get a categorical list of Excel functions, you can press F1 and then search for functions by category. And then click on the Excel Functions by Category link. As you navigate through the different categories here, you will notice that some functions have version markers next to them. These markers indicate the first version of Excel when this function was made available. If you prefer to get a complete list of Excel functions without the categorical breakdown, you can go up back into the search bar and search for Functions Alphabetical. And then click on the Excel Functions Alphabetical link. Lastly, you can use the Insert Function dialog box from under the Formulas tab on the ribbon bar to review the general usage of a function, the different arguments that it expects, and the definitions for each one of those arguments, the expected formula result at the bottom of the dialog box, and also a link to access additional information regarding this function. Clicking on this link brings us to the Microsoft documentation page for this function, where you will see additional detail about the function, possibly some videos regarding the usage of the function, information regarding syntax, some additional examples for the usage, and other notes and common problems to expect when using this function. With all this information on hand, you can determine functions best suited for a specific requirement and review other relevant information to easily incorporate them into your models. Most data analysts working within Excel depend on arrays for complex calculations and problem solving. In fact, most of us have used Excel arrays without maybe realizing it. An array within Excel is a list of values or cell references. The current slide highlights a one-dimensional vertical array consisting of all row headers from the leftmost column, a one-dimensional horizontal array consisting of all column headers from the top row, and then finally, a two-dimensional array consisting of all data highlighted in yellow. When writing array constants, a comma is used as a column delimiter and a semicolon is used for a row delimiter. So in the example shown here, the one-dimensional horizontal array can be entered as an array constant with all column headers separated by commas, and the two-dimensional dataset can be entered as an array constant with all values within a row separated by commas and with a semicolon following the last value for each row. Array data in Excel is processed using array formulas. An array formula performs calculations on data within one or more arrays using Excel functions to generate an output in the form of a single value or possibly a list of values. Typical uses of array formulas include generating randomized sample datasets, which would be covered in a more intermediate or advanced course, conditional aggregation functions on a range of values, for example, countifs, sumifs, and so on, data filtering and lookups, and matrix multiplications and manipulations. For Excel products prior to the latest 365 suite, including Excel 2019, an array formula that could process multiple values or return multiple results had to be confirmed with the Control-Shift+Enter key combination. These formulas were thus typically referred to as CSC formulas. For easier identification, such formulas were displayed with curly brackets around the entire expression. Starting with the September 2018 release of Excel for Microsoft 365, array formulas can be confirmed just like other Excel formulas using the Enter, Tab, or arrow keys. Depending upon the result format, the result is either placed in the same formula cell for single values, or it may be output, down, across, or in both directions from the formula cell, depending upon the resulting array structure and size. This latter behavior is called spilling, and the formulas that return arrays of variable sizes are called dynamic array formulas, which typically include dynamic array functions. These are built-in or user-defined Excel functions that can output one-dimensional or two-dimensional arrays to adjacent cells. At the time of this recording, the following built-in dynamic array functions are available within Excel. These functions can either be used individually, or they can be combined with each other to reduce the number of steps in getting to the desired output. As an example, we can use the filter function to return the values from the list on the left that are less than 10, and we can also combine the same formula with the sort function to return the results in a sorted list as shown in the second example. It is important to note that the spilling feature in Microsoft 365 Excel is crucial for the dynamic array capability. It is thus pertinent that we spend some time understanding the spill behavior in Excel and the corresponding errors. Our next topic will cover these in further detail. As a data analyst designing and implementing Excel-based solutions, it is important that we understand the spilling behavior in Excel, the relevant constraints, and any errors that we might encounter. As discussed earlier, depending on the output array structure and size, dynamic array formulas will place the resulting values down and or across from the formula cell, which is often referred to as the starting cell. The cell range where the results are placed is called a spill range, and the formulas that successfully spill are called the spilled array formulas. Now let's review some attributes of the spill behavior in more detail. Once a dynamic array formula spills its results, the boundaries of its spill range can be easily identified by clicking on any cell within the range. When clicked, the entire range is highlighted with a colored border. In case of some spill errors, which we'll review in more detail later in this lesson, we will typically click on the starting cell, which is the cell with the error, to review and clear out the corresponding spill range. Once cleared, the spill data will automatically fill the entire range. When referencing spill ranges and their values in other formulas, the starting cell of a spill range can be referenced by either using explicit references or defined names. If we want to reference all data within a spill range, we can use the spill reference notation, which requires a pound symbol after the starting cell reference. This reference notation works for both explicit cell references as well as defined names for the spill range starting cell. We can also use one of the lookup functions within Excel to refer to a specific value within the range. In this case, we use the match function to look for the numeric value 3 within the range and return its index. The implicit intersection operator, which is the @ symbol, which we'll review in more detail later in this course, can also be used to reference a value in the same row of a spill range as the currently selected formula cell. Apart from these attributes, the spill behavior is also subject to some constraints. It should be noted that this capability is not supported within Excel tables. This might be obvious since Excel tables will typically have other data around the formula cell, which would limit the spill. Additionally, at the time of this recording, dynamic arrays and the relevant spill behavior have limited support across workbooks. Formulas using this feature will not work unless both workbooks are open at the same time. There are a few other scenarios where spilling might fail and result in a spill error. Excel for Microsoft 365 thus includes specific error messaging related to the spill behavior. Now let's review these spill errors and some ways to troubleshoot them. Spill errors are returned when a formula returns multiple results and Excel cannot return the results in a grid or display them in the corresponding spill range. Specifically, spill errors may be returned for one of the following scenarios. Spill range is in blank, which means it has existing values, formulas, tables, etc. within the range. In this case, as soon as we clear out the cells that have the data, the spill will work as expected. Intermediate or volatile size, which means that the spill range will need to resize between calculation passes. In this case, we're using the sequence function with a random number as its argument. So as the sequence function tries to determine the structure and size of the resulting spill data, the random number would change, which in turn would change the size and structure of the resulting spill data. Thus, it just never gets out of that loop, which means it never displays the result on screen and results in the error. In such cases, we just need to use a different combination for functions, or maybe use a different approach to solving our problem. Another scenario is where the spill range extends beyond the worksheet's edge. As an example here, we're using the sequence function to generate a list of numbers in 1,048,576 rows. However, that's the maximum number of rows allowed in Excel. If you account for the additional rows at the top of this formula cell, this will go past the spreadsheet's edge, and thus this results in an error. A solution in this case is to just use a smaller argument and allow for the spill to work. As discussed previously, spill ranges will also not work with Excel tables. If you think about it, the spill data from one of these cells would probably overlap other content in the table. This would result in the first spill error that we discussed, where the spill range isn't blank. We would also encounter a spill error if a merged cell is within a spill range. In such a scenario, even clearing out the merged cell will not result in the spill working. The solution here would be to unmerge the cells, and the spill data will work as expected. Other scenarios for spill errors would include out of memory, where we might want to try a smaller range or an array, and unrecognized or fallback, which is for errors where Excel can't recognize or reconcile the cause. Now that we have covered the spill behavior in sufficient detail, let's review another relevant topic, implicit intersection. Implicit intersection is another important concept for data analysts working with Excel. For all Excel products prior to the dynamic array-enabled versions, this behavior was used by Excel to reduce multiple array values to a single value using the following logic. If the value is a single item, then return the item. If the value is a range, then return the value from the cell on the same row or column as the formula. If the value is an array, then pick the top left value. In these versions of Excel, the implicit intersection logic was executed behind the scenes, as a single cell could only hold one value. The exception here would be Excel tables, which allowed users to reference cells in another column of the same row using the implicit intersection operator, which is the @ symbol. However, with the latest Excel for Microsoft 365 versions, this operator is used to reference values within a data range that are in the same row or column as the formula cell. In essence, it allows Excel users to explicitly disable the dynamic array behavior and return a single value. In case the resulting value is an array, this operator will return an error. Implicit intersection can also apply to user-defined functions, however that is out of scope for this course. Now let's review some examples for this topic. For these examples, we will consider three dynamic arrays: a one-dimensional horizontal array with all the column headers, a one-dimensional vertical array with all the row headers, and a two-dimensional data set. To start with, let's use the implicit intersection operator to retrieve values in the same column as a formula cell. To do this, we will type in the implicit intersection operator, which is the @ symbol, followed by the define name for the starting cell of the spill range, and then finally the pound symbol for the spill reference notation. This will help us refer to the entire spill range. When we press enter, we can see that it retrieves the value in the same column as the formula cell from our column headers spill range. It is important to note that our result does not change if we use the same formula on a different row of the same column. Now let's use a similar approach to retrieve values from our row header spill range in the same row as a formula cell. Once we press enter, we can see that the retrieved value is from the same row of our row header spill range. We can also try to use the same formula in a different row and column and expect to see a result that is from the same row as the new formula cell. Finally, let's try something a little bit more complicated. With this function, we want to retrieve the value from the second column of our two-dimensional data set, which is in the same row as the formula cell. The third argument for our index function provides the column number. The first argument provides the spill range we want to refer, which is our two-dimensional data set. And the implicit intersection operator at the start, the @ symbol, tells Excel that we're looking for the value in the same row. The trick here is to use 0 as the row number argument for our index function. This, in combination with the implicit intersection operator, tells Excel that we're looking for the result from the same row as our formula cell. When we press enter, we can see that the retrieved value is from the same row as the formula cell and from the second column in our two-dimensional dataset. Okay, so with that, we have now completed our review of some important topics related to structuring and referencing of data within Excel. Now let's try to incorporate these concepts into a relatively simple data analysis solution. Let's consider this table with scores for students in different grades. For our solution, we would like to get the details for top 3 students for a selected grade. We will take a step approach to getting the desired results so that the solution is easier to follow. For this exercise, I've already set up a structure and defined names for our spill ranges so we can focus on other concepts and formulas. The defined names are listed in italics above each dataset. To start with, let's use the filter function to get a list of students in grade 1. For this formula, the first argument of the filter function is the student data table. The second argument filters that data table where grade equals 1. And the third argument provides the message that needs to be displayed in case there are no results found once the data is filtered. As we press enter, we can see our filter data set displayed in a spill range. As a next step, we will use the sort by function in addition to the filter function to sort our filter list of students by their score. For this formula, we replace the first argument of the filter function by the sorted list. The sort by function takes the original student data table and sorts it by the score column in descending order. We still maintain our filter for grade equals 1. However, as we press enter, we notice that there's an issue with this result. We still have a grade 2 student showing in this list. Now let's review our formula again. Here, the first argument of our filter function is a sorted list. However, the include argument expression is still using the unsorted table column reference for the index of rows to return as part of the result. Since the sequence of records in the sorted and unsorted lists does not match, we get an erroneous result. To fix this, we will change the include argument to use the same sorted list that we're going to return the results from. So we will copy the expression for the sorted list, replace the first part of the include expression, and since we're only comparing the grade column, we will append that to the first argument of the sort by function and press enter. As you can see, we now have the correct filtered list sorted by score in descending order. Next, we will use the index function in conjunction with the formula we have authored thus far to get a list of students with the top 3 scores. For this, we will use a couple of array constants. First, we will use an array constant with 3 separate records, one for each row number we need from the filtered list of students. This is essentially the rank for students we need on each row of the new list. As we have already discussed, we use a semicolon within array constants to specify new rows. So in this example, we will place the required ranks on separate rows of the array constant, with each separated by a semicolon. As we press enter, we will notice that the result is a single column spill range. This is because we skipped the column argument in our formula, and using the implicit intersection behavior, Excel returns the leftmost column by default. Now let's provide an appropriate column argument so we get the name and score columns as part of the result. Note that we want to select the column fields as part of each row, and we have already discussed that a comma in an array constant can be used to separate fields in the same row. So in this example, we will use an array constant where we specify the index of each field that we want displayed for every row. So in this case, the name is index 2, and score as index 3. Then we close the curly brackets to confirm the array constant, and then press enter. As you can see, we now have a list of names and scores for the top 3 students. Now this setup will work for grade 1. However, we would need to manually modify a few formulas if we want to display a similar list for grade 2 students. So let's add the ability to have our top 3 list be updated for a selected grade. While there are a few ways to implement this, we will stick to dynamic arrays for this example. Let's first generate a list of grades available within our table. We will use this list to populate a drop-down where we can select the grade to filter down our top 3 student list. In this case, we will use the combination of the sort function and the unique function. The unique function here gets a list of unique values from the grade column in our student data table, and the sort function basically just sorts that in an ascending order. As we press enter, we'll notice that our grades in table list is consistent with our student data table. Next, we will define a name to reference this grades in table list. For this, typically we would click on the Name Manager button under the Formulas tab of the ribbon bar, and then click on the New button to define a new name. However, in this case, I have already defined a name referencing the list of grades in table. As we open this name definition, we will note that the name is listed as T3S, which is just a short for the sheet name, and then grades in table. It then references the starting cell of our spill range, and then uses the spill reference notation pound symbol to reference the entire range. In this example, our defined name will always dynamically update for all grades in our student data table. We now click OK to get back to the Name Manager, and then click on Close to get back to our Excel sheet. After defining the name, we will now use the data validation capability within Excel to use the list of grades for a dynamic drop-down selection. We will discuss this topic in more detail later in the course, but for the purposes of this exercise, please note that data validation within Excel is used to restrict the type of data or the values that the users can enter in a specific cell. One of the most common data validation uses is to create a drop-down list, also known as a data validation list. Before dynamic arrays, there was no easy way to create dynamic data validation lists. We were restricted to functions like indirect, which have their own challenges due to the use of static text references. So now let's see how easy it is with dynamic arrays to create a drop-down from our dynamic list. To do this, we first want to select the cell where we want to display the drop-down, then go under the Data tab on the ribbon bar, then to the Data Tools group, and then click on the Data Validation button. Here, we want to select the List option for the Allow setting, and then for the source, we want to provide a list of values that we want to display in the drop-down, or maybe a cell or range reference for a similar list. On the other tabs, we can provide a friendly input message for the users, and also an error message in case of invalid data entry. Once done, we can click on OK, and then confirm if our data validation list has the options we expect. For additional testing, we can also update the grade for one of the students to, let's say, 3, and then make sure that our grades in table list is automatically updated for the new value, and also that our drop-down includes the new grade value. Once done, we can revert back to the original data set and carry on with our example. So at this point, with the spill range that contains the unique grades from our source data table, the defined name that refers to this spill range, and the data validation that uses the defined name to create a drop-down list, with the selection of the same unique grade values, we now have a structure in place to select a grade from a dynamic list of options based on our source data set. Next, we need to update our dynamic array formulas in the 3 data sets above. To do that, we should probably define a name for the cell containing our drop-down list. This will help us to easily reference the selected value in the formulas above. In this case, I've already provided a name for this cell, which can be confirmed within the name box in the top left of the screen. Now let's update the formulas to use the new name. So for the first formula here, where we're getting a filtered list of grade 1 students, we will replace the 1 with the selected grade. We'll do the same for the second data set here, and the same for the third. As you can see that none of the results have changed at this point. That is because the current value for the selection from our dropdown is the same as what we had before, which is grade 1. Now let's try to change the selection here to grade 2 and see the results. As you can see, the 3 lists above have automatically updated for grade 2 results now. So with this example, we've shown that dynamic array functions can be combined with other Excel functions to allow for more complex data processing and array output generation. They can also be used to define names for dynamic lists, implement dependent dropdowns, and generate valuable metrics for more advanced data analytics capabilities. During the next lesson, we will look at some practices for preparing our data for analysis, and then look at a couple of more advanced data analytics solutions.